Good morning, everybody. So I guess we can get started for the second day of research-based learning symposium, now in Scuola Normale Superiore. So we are going to continue with the approaches, research-based learning approaches. The last session, but the last speaker is sick, and unfortunately he's not going to be able to join us. So we may have some time flexibility for our speakers because of that. So we can get started with our first speaker from Bucharest, Radu Ionut, and his speech title is Relationship Between Industry and Academia at UPB Following RBL Concept.
So, thank you for your kind introduction. I'm very happy to be here today. And my presentation will be about the relationship between industry and academia in University Polytechnic of Bucharest, but not at the university level, just one department from one faculty where I'm working there. So, I'm coming from University Polytechnic of Bucharest, Faculty of Chemical Engineering and Biotechnologies, and the department, Bioresource and Polymer Science. For the bachelor students program, we have two domains, one chemical engineering domain with one specialization, as you see here, science and engineering of polymers, and the second domain with two specialization, applied engineering science. So today mainly I will discuss about chemical engineering with specialization, science and engineering of polymers, the industry relationship in this specialization. In the department, I'm an assistant professor. I have some activities like teaching activities, supervised activities, master thesis, graduation projects, and so on. I have also some research activities, like a researcher and a project coordinator. And also I'm a supervisor for the technological practice of the students. I'm, let's say, in charge a little bit with the relationship with the industry in the department, at the department level. So probably because of that, I'm very interested to work with the industry, to have a strong relationship with and make new connection year by year. In our department, I would say that the relationship with the industry is classified in two directions. One direction just based on the technological practice of our students. They can develop their practical subject in some big company, like you said there, in food industry, automotive industry, paints industry, tire industry, and so on. And the second, let's say, type of partnership developed in time in our department is a little bit more complex. It's based on research and development, in collaboration with the industry. And I have here just two examples of two companies from Romania. A company named Valorom, which is part from a bigger group, Valsir, which is a leading company in polymer processing in our country. And second company is Green Group. It's a company which has activity like materials recycle, mainly polymer recycling. I think it's first in Romania and among three in Europe. And for today, I choose to discuss only about one relationship with one company with Valorom. So the idea is that they try to make a direction related with the polymer recycling, just mechanical recycling of polymers. So being an issue in the recycling of polymers, for the environment, as we know, many companies in Romania, having some connection with the industry of plastic, to try to recycle, to have mechanical recycle. So besides the raw material, they try to develop their own secondary raw material in order to have added value of the polymeric waste. So also for the Valorom, this is a new topic. So the idea is they want to develop a new direction, on the mechanical recycling. So the collaboration between academia or department, okay, is strong with this type of industry, with polymer processing, with recycling. So in this partnership, I would say that their role is to have a source of polymeric waste, okay, to produce some flakes, to produce in general they produce pipes, okay, so at the industrial level. And our role in this partnership is to assure support, research support for them, to make some recipes, to make some mixture for the industry, that the recipe to be applied directly in the industry, and different types of characterization, analysis, something specific, mechanical analysis, and so on. And also produce some products at the laboratory level, let's say, and after that go in the industrial level. So for that we need some support, let's say, from the students. And today I'm going to tell you, let's say, a story of our two bachelor's students, fourth-year bachelor students, their graduation project. So the subject of their graduation project was given by the industry, by the Valorum, okay, and they also have a scholarship, okay, for this direction. So what they have to do? An evaluation of the plastic waste source in Romania, and also the idea, what can we do with the plastic in order to have some added values to produce new materials. So first they have to make like a report, okay, in order to see the companies in Romania which are, let's say, able to produce some plastic waste, okay. See the companies, with the contact, we see the types of material that can be provided from the companies. First, they have to go to the company, discuss with them, take some samples, like we see there, make some analysis, characterization, and after that, go to the research. I have here an example of some waste products from the automotive industry, from Moreno, Dacia, some material named polypropylene. The idea is that the research for the mechanical, not just for the recycling of polymers, is very, very complex and requires a lot of effort. Okay, time, okay, money for the equipment, and the involvement of some people with a lot of expertise in the processing of polymers. So what are we doing now is just produce some recipes, okay, for them by adding some additives and specific additives in specific concentration, as we see there in the images. And after that, we have to go to produce, okay, to have the produce at the laboratory scale, and after that go in the industry scale. As you see there, after we have the recipes, try to make some analysis, okay. You can see here their work, the students' work in the laboratory for a characterization of materials and producing materials in the laboratory scale. Okay, as you see here, some results in the right. Okay, some tubes. We produce tubes in the industry. They produce pipes because tubes are smaller. They can be produced in laboratory scale. You can see here the results for direct production of tubes without, okay, no additives and no processing. And in the left, their work, okay, their results with some proper manufacturing process that can be, okay, taken in the next level in the industry for sure. Okay, and what they have to do to make a report, monthly report, and also a final report, which comprise some work methodology, what they have done, recipes, okay, substances, and so on. Research results, observation, requirements, okay, recommendation for the industry. After that, they have to go to the industry, okay, to see their result, to follow the industrial process, okay, to see the results, to have some observation, recommendation, and if there something is going wrong, let's say, we have to go back, okay, with the students in the laboratory to make some adjustment of our recipe, and go back again to the industry, like a, okay, it's like a circle, a closed loop. And I think that this idea is a good activity of research-based learning, because they have to learn how to do a project, a report, how to have a critical view, to work in a team, okay, to solve some problems, and so on, and also to have a good activity, okay, in the industry. Another idea on the slide, it's a comparison of curriculum from one of my courses, okay, where we discuss the theoretical, let's say, approaches for some classes of additives, and in the right, the class of the additives they used in their research, okay. So basically, they are the same. And what's important to see this approach from more practical point of view. Probably at the end, the students won't be able, okay, to reproduce some complex definitions, okay, of the substances, but for sure they will know which is the role and strong, let's say, support of the substances in the industry. So more from the practical point of view, I think is more important in comparison with the technical, with the just see, okay, the classes. And some conclusion based on their projects, I would say that the research-based learning concept has to be highlighted like a teaching method, because this concept okay, promotes, creates new abilities for the students, okay, to work, to have collaboration, to work in a team, to solve problem, to have a critical view. It's very, very important, because this approach prepare you, and probably it's a training for the students to be able finally to work in the industry, because this is very, very required there. Okay. So, thank you.
Thank you, Radu. Thank you very much for the presentation. Are there any questions? I have a brief question for you.
Sure.
Maybe Bersam.
Thank you for your presentation. It's very valuable subject, you know, the recycling activities. But I wonder that maybe I skipped, but do you use team? You work as a team or only one person?
They work as a team.
As a team,
both students.
Okay, teamwork, because it's
a teamwork, yes.
Important because they can learn from each other also.
They have to work
when they conduct the research based on laboratory, because they can learn each other.
Okay, they have to learn each other because there are some complex equipments and cannot work individually. Have to be two people or three in order to produce something. Okay, it's very, very complex work.
And is it typical procedures for your graduation projects, or?
It's not quite typical, okay, but we're trying to do something more practical. This is important, okay? This is the future from my point of view. To work with industry, to have something valuable which can be used in industry for the society.
Yes, thank you. Thank you very much. Okay.
My question is about how you create these relationship between the industry. Is it based on the personal relationships of the faculty, or is there an office that actually manages?
At the beginning, it's more personal relationship, okay, discuss with the company, okay, go them, see their activities, and after that, okay, discuss with them if they have something to do which is their main activity, something we can do for them besides the technological practice of the students.
Thank you. Any other questions? Okay. Let's thank the speaker, and we are going to move on. So, our next speaker is Michael Morello from UPM, and he is going to speak. Where is the presentation? From SNS, yes. The title of his presentation is a laboratory course, The Challenge of Teaching How to Make a Real-Life Experimental Measurement. Can we have the presentation?
Can you hear me? Yes.
Does it work?
And
I'm not sure if that microphone works.
I don't know.
You can use this one. This works.
Yeah,
but
let's
you
try.
want to hold like this.
be on. But can you hear me very well?
No, I don't.
No?
I don't think that works.
Okay, it doesn't work.
Let me check.
Ah, okay, maybe. Okay, thanks. I don't know, let me try, okay? Okay, good morning to everyone. And first of all, let me thank the organizer for giving me this great opportunity. I am a physicist, I work in fundamental physics, and okay, my link to the industry is not so strong as other speakers, but I will try to bring here my experience as a physicist. And okay, first of all, I would like to introduce me and myself. I am an experimental particle physicist. I am an associate professor here at Scuola Normale, and I work at the LCB experiment at the Large Hadron Collider at CERN. And okay, my research is mainly focused to of course, build the experimental apparatus to make final measurement. And in LCB, we try to answer one of the most fundamental questions of fundamental physics, which is why we are made of matter instead of antimatter. And to do that, we just study process of bottom and charm quark systems. And I also do research in developing and implementing specialized processors with new architectures based on the so-called accelerator. I am specialized on using FPGA, just because we would like to make a reconstruction of our proton-proton collision events at 40 megahertz to reconstruct frame every 25 nanoseconds. But today I'm not here to talk about my research. Of course, it's strictly related to my research, but since my research, I have been the honor and the privilege to teach many courses during the years here at Scuola Normale and at the University of Pisa, which is very close here at the end of Via San Lorenzo, a few meters from here. And I have the privilege to teach courses in physics, statistical data analysis, and of course of particle physics and many years. And here I bring my experience, in particular for the laboratory course. Okay, first of all, I have a disclaimer. Please accept my apologies. I will try to make to share with you some comments and thoughts which are, in my opinion, universal, but of course I will link to my area of expertise, which is experimental high energy physics. Okay. Okay, we are talking about making a real measurement. I think that this topic can be of inspiration also for other area. And here I tried, of course, I tried to understand nature. And, but this is also for many other things. And here I tried to make a simple sketch of 4 main stages to perform a real-life measurement. First one is the stage 0, that you have to plan to design to build your experiment. Of course, you have a target. You want to measure something, or you have a set of measurements that you would like to do to understand something. And you have to design, build, and run the experiment and collect data. This is the first most important part, and you need some data acquisition system, of course, to achieve this goal. The second step is the data storage and the data processing. And usually when you collect data, this is independent of the size of the experiment. Of course, if the experiment is big, you need a huge amount of computing power. But usually you need to run complex algorithms to reconstruct things, to refine your data, to image processing, whatever you want. And you need to use computer science and modern technologies to do that. And the second stage, which is the third one in my sketch, is the analysis of data, which is another very important part of this task. And at the end, the final goal is to have a measurement where you assess the final statistical and systematic uncertainties. And then you have to publish your result on a peer-reviewed journal. And you need to explain, to present your result, but in particular, you need to explain the approach that you have adopted and to show they are very robust, because those results and those strategies, those approach must pass a very demanding internal and external review, with which the word internal I intend first the review of the experiment, that in my opinion is the most demanding one. Okay, as you easily understood, this is not just a single discipline, a single task. And you know very well that this is true in science, of course, but for the life of an experiment is really tough, and whatever the field you are researching on. And nature, that's my case, is not benevolent, and he takes all its secret very, and it's very, very hard to try and understand how things works and how nature how nature try to explain how particles interact with them. Okay, first of all, the first ingredient that you need a very deep knowledge of the process of the phenomenon that you would like to study, and this result since many years of study. And this is true for physics, chemistry, biology, nanoscience, engineering, whatever you want. But when you would like to perform a real measurement, you need also to know very well many tools and many other expertise. And here, for instance, in my field, it's very essential to know the experimental apparatus. You need to know how work sensors, electronics, the system of data acquisition, and sometimes you need also to program in very low-level language program languages. And this is not trivial. You need to assemble your detector, and in general you are interested in very rare phenomenon that we call signal, and you want to disentangle this signal from a huge amount of unwanted events. This is background. And you need also to set up, to do that, you need to set up an efficient and intelligent system of data acquisition and trigger. This is what we call trigger. And in many cases, in experimental science, you don't find any of these hardware-software objects commercially available on the shelf, because you are trying to do something which is new. And sometimes you need to build by yourself new things, okay? And this is also the very nice and part of the job. And the last step is collecting and handling data. And to do that, you need to know very well data analysis software package, which is not trivial. And also an essential ingredient is the knowledge of the statistical inference concept. And this is now something which is very serious, because the interpretation and how do you present the result to the community is something which is extremely important. Okay, how do we prepare students to face this challenge? I have to be really honest, and I think that preparing a young undergraduate student to face all this is a very hard task, and the fraction of success of this is not so high, at least for the first part, but we try to do our best. For a PhD student, things are easier, but it's not so straightforward, because the PhD student has much more time, is already trained because he's graduated, and he already focuses all his time on doing research, in our case to make some experimental real-life measurement. And the PhD student, of course, has always the guidance of a supervisor, or in many cases also more than one supervisor. But even in this case, as I already mentioned, this task is not so straightforward. I advise many students, and this is a tough job. As a teacher, what we can do is just to show students, undergraduate students, how an experimental problem must be approached, and what are the best practice to follow by pointing the right way. This is my opinion. And then how do we do that? Okay, and the first stage of this process is, of course, the laboratory course. This is a universal concept, and this is a nice picture of a laboratory here at the University of Pisa, where you can see a bunch of students divided in groups very close to their experimental apparatus, so they try to make some real-life measurement. This is the very first touch to experimental science. Of course, we have laboratory courses at the first years of the university, which are simple, okay, basics, but when I arrive at the end of your path, you will have to face some laboratory course in which you are supposed to make some real-life measurement from the start to the end. Okay, those courses are extremely important in experimental science, and they aim at providing all the intellectual skills to face and carry out an experiment on its own stage. For the first time, students face the real life, which is, let me stress this concept, very different from textbooks and simulation. It's a completely different universe. I can make sure this is true. Students are supposed immediately to use all their cultural know-how, everything they learn in the past in all theoretical courses, and simultaneously they have to learn a new concept, and they have to master a completely new environment. This is not trivial. I can assure you that when they arrive at the fourth, the fifth year of the degree, is not very simple to face this challenge. And of course, when you try to do something for real, there are bugs, there are mistakes, there are problems, and everything can be very frustrating, okay? And for the first time, I think that the students ask himself these fundamental questions. How do I convince myself and my colleagues that what I'm doing and what I'm measuring is correct? This is something very important for an experimental scientist, for an experimental physicist, okay? And this is not trivial to teach, this kind of stuff. Okay, what we do is just to propose some real-life experiment to students in our laboratory course. And here you can see just an example, a form, sorry, is in Italian. And the first thing, I think, which is very important is to propose a target which is very well defined, okay, which is real and which is very well defined. You want to measure in physics observables or some properties of a material, whatever you want to do. And this must be very similar to the cutting edge research that you are doing in that moment. Of course, you cannot propose your student to help you in your research, because you need to have an environment which is fully controlled from an experimental point of view. This is very important, because when problems, mistakes raise, you must be able to solve this just looking at the plots, to the distribution, to the oscilloscope. You, as a teacher, you don't have to touch the experimental apparatus. This is the job of the student, okay? The instruction and the guidelines on the instrumentation, on the equipment, must be very comprehensive and clear. Data sheets, how they have to assemble their own experimental apparatus, the safety rules. You have to imagine that this is the first time that they face this kind of challenge. Time is also another very important player of the game, because students have a limited amount of time to do something which is very difficult at their age. And you need to prepare something that they can be done in just 1, 3, 4 weeks. Usually we give them 4 weeks to perform this kind of experiment. And of course, within certain boundaries, this is in any case a course, so you have to keep in mind this. You need to allow students to explore new approach to optimize uncertainty, to do better and better, because they must feel that if they have a new idea, they need to apply them and to try to reduce statistical systematic uncertainty. This is very exciting. Just an example of what we do in particle physics. For instance, here there is an example in which we ask them to measure for the first time the mass of fundamental particle, the electron. You know very well what is the electron, okay? It's a fundamental particle of the model. And maybe you know the quantum mechanics, but there is a very simple relation which links the energy of a photon which scatters in the matter because colliding with an electron. And if you measure the energy of the incident photons and the energy of the photons after the scattering. You measure the angle with this experimental apparatus. You are able, from this equation, to measure the electron, the mass of the electron. This is very, very nice. And this is done by students at the 4th, at the 5th years of the undergraduate student degree, when they just passed 2, 3, 4 years on the books to try to study how the standard model, the particle physics work, and it's very exciting. Of course, you need to suggest them all the procedures and the experimental measurement that they need to do, because they need guidance. This is very important. They don't need that you are going to solve the problem. They need guidance to know what they have to do. Okay, you can imagine that this is a very hard job, but there is a lot of fun to do that. I don't want to go into details, but you can see plot, experimental apparatus, distributions, and at the end, for instance, they measure this parameter with a relative uncertainty of few percent. This is, of course, this is not precise as we specialists measure this parameter, and you can see in the particle data group, which is our main book with whole particle physics measurement. But measuring with the 2% level of accuracy, a so important parameter of the standard model, is something very important for the students at the 4th, the 5th year of his degree. And note that 1 kilo electron volt corresponds to about 10 to minus 33 kilograms. You are measuring something which is very, very outside the classic things that you do in the laboratory. Okay, let me just, the time is short, let me just make some further consideration. The first things, you understood that you need skills and knowledge, and students arrived to this course already trained in previous theoretical and experimental courses, but in the laboratory they need to use everything that they learn in the past lecture, in the past courses. This is very, very fundamental, because you need to use whatever you have learned in the past. Theory, software, statistics, electronics, and this is a step which is not trivial to the first time to face. Guidance. Teachers, we need to guide them, okay, and the very, very nice experience, and to sit down with them, to look at the distribution, to look at the oscilloscope, and understand where is the mistake, where is the bug. Okay, this is the best lecture, the frontal lecture that you can give to a student in a laboratory course. Okay, you don't have to touch the experimental detector, the experimental apparatus, but just looking to the signals, to the oscilloscope, to the distribution, you can teach how make a real life measurement to a students. Okay. A guidance is a very, very important thing at this level of the degree. Systematics, okay, this is a very important chapter, and I want to spend a lot of time, but systematic uncertainties at this level is still a mystery for the students. And textbooks covering this topic, I can assure you, do not exist, okay, because the systematic uncertainty is different cases by cases. You cannot write just a book defining what is the systematic uncertainty and describe all possible cases that you can meet in an academic research life. Blindness, okay, I found that it's very, very helpful to propose experiment, even using pure simulation, of course, in which you don't know the true value of the parameters that you want to measure, because we, as a scientist, when we measure something, in the majority of cases, we don't know the final number that we are measuring. And then you have to convince yourself that you are doing the right thing without knowing the value of the things that you are measuring. This is a very, very important point. Sometimes when we measure a quantity which is very well known but with higher precision, we blind our result because we don't want to take any decision just looking to the final value that your data return to you. Okay, those are very important points. Let me conclude. Okay, I think that I gave you in these 15 minutes an example of research-based learning education approach. And I have to admit that in physics, this is something which is not very new. What is new, in my opinion, is that now we have many tools to allow this approach to be very effective, very efficient, and to help students to arrive in good shape when they need to face a real-life problem, a real-life research problem in a laboratory when they are postdoc, they are young scientists, and also those are universal things that are very helpful for all life. Okay, this is even, let me just make one more comment, and I think this is even more relevant in a world where very powerful and amazing tools are emerging, and I'm referring to not only to the computer science, but in particular to the artificial intelligence, to the machine learning, supervised or unsupervised, okay? Those are amazing, they are very, really powerful, and they allow users to manipulate, to know, to understand the data very quickly, and they are extremely important for scientists, for industry, and for all, and in particular for experimenters. But they open an infinity of opportunities that we would like to grab, and we would like to profit of this, but here we are in Pisa, and it's very, very important to profit them in any case within the boundaries of the principles of the Galilean scientific method. This is very important, not only for experimenters, but I think in every area. And nowadays, okay, the researchers, the teachers have this big responsibility of preparing the new generations, you guys, for the challenge that waits us, and I think that Scuola Normale, that EELISA partnership are a very good position to help you to succeed in your endeavor. Thanks a lot.
Thank you, Michael. Any questions?
Hi, thank you for the presentation. Of course, measurement is very important in industry.
Yeah.
I'm just curious if you have partnership with meteorological national institution organizations. And this is one question. And the other one, I saw bachelor students, they are doing measurements, but my question is also if you teach them how to do the calibration of the instruments. Thank you.
Okay, for the first question, yes, of course, we have many collaboration with many institutes, many meteorological institutes, and partnership with the industry. You have to imagine that, for instance, CERN is a big laboratory, and they are collaboration with Microsoft, Google, with the foundries for the silicon, and this is a very important part of our life. Of course, we have a different kind of specialization, but we would like to profit of the development of technology. And of course, sometimes we discover something which is very helpful to the industry and for the progress of our real life. The second question is the calibration. Yes, the calibration is a very important part. And for instance, in this example, you can see, in this example, you can see the position of these peaks, which are the two photons, and you need to measure the position of these two peaks when you change the angles of the scattering. And these two plots are just the calibration of the energy scale of the photons, because here you see there is no energy, but just there is an ADC channel, and you must use different photons with the different known energy to calibrate not only the scale, the absolute scale of the energy, but also the response, the resolution, how you are able to measure this energy. And this is one of the most important parts of doing a measurement, the real life measurement. Calibration is, and systematics related to the calibration is one of the most crucial important points.
Thank you so much. Apologies, I'm not a physicist, nor coming from the main sciences. I'm an architect, but just wondering, you mentioned that is for 4th and 5th year students. My question is it something like a compulsory something like compulsory laboratory course for the graduation or fulfillment of a degree? Or what is the status of this lab in terms of regarding the curriculum? So is it something for
I don't know. I don't know if I got the question. What we do in physics, okay? We have different curricula, and of course, if there is okay, the first 3 years is very similar for all students, but of course, all students must follow not only theoretical courses but also laboratory course. Of course, at the first year, you have simple experiment. Okay, I don't know. You study the pendulum. Okay, this is a very classical experiment in which you measure the gravity. For each year, you have a different laboratory. When you arrive at the end of your degree, fourth and fifth, you have a laboratory which are specialized in particle physics, in material science, and depending on what you want to do in your academic research life. And this is part of your curriculum. Okay, this is a very important part of your curriculum, and even at PhD, this is part of your curriculum. You can choose to do some laboratory course.
I see. That's why you have these complementary modules that are collide into this.
Yeah, sure. Okay. For instance, here in laboratory, I don't have this kind of laboratory, but I have a laboratory of analysis data. I propose experiment just giving the data in which I blend the measurement that they need to make.
Any other question? Maybe one.
You mentioned that students need to get to know the devices and the equipment they use, etc.
They need to know, sorry?
They get to know the equipment, the setup.
Yeah.
I was wondering how fundamental can you go in terms of the devices you need to use to make the measurements? I know that it's part of the education, but for instance, you need to measure the energy here. So all of a sudden, you require a device that needs to measure the energy. So you are trying to measure the mass, but you need to measure the energy to do that, and that's a whole other subject. So it goes in a sequence, and my question, I guess, is where can you, or rather, how can you simplify it as much as possible, or is it really helpful, or maybe is it better to familiarize the student with as many such devices as possible so that they can use different things with other measurements?
Okay, this is the hard part of this job. Of course, you cannot teach everything, and you need to make, this is particularly true, I think, for physicists, because they need to face something which is completely unknown, and depend on the problem that you would like to solve. I don't know, this is also true for the theoretical physics. Sorry, I am a physicist and then I talk about physics. I don't know, Einstein, when he tried to solve the problem of general relativity, he had to develop by himself the mathematics, the tools to solve his own problem. And what we do physicists is the same thing. You want to measure something that has been never measured in the past, and sometimes you need to develop skills that no one has in the field. Of course, you would like to profit of what we already learn, not only in research, but industry, in electronics, in computer science. This is the peculiarity of human being. And of course, you cannot teach everything. And for instance, it depends on the level of specialization that you need to achieve to get your goal, the final goal. And you can have some standard things that everybody needs to know, and this is what we try to do with software, with electronics, some basics. But at the end, when you go forward through your academic science, and your problem become even more difficult, sometimes you need to study new things and to develop new approach. And this is also, I think, the nice aspect of this kind of job for us, that we are pure researchers with just looking for fundamental law and hoping that at some point we will have some real-life application. I don't know, internet and electromagnetic waves, now they are spread everywhere. But you have imagined Faraday in the 2 centuries ago studying this kind of things without any kind of applications. But he pursued and to understand how these things works. And after 2 centuries, now we are all the smartphones, computers, and and all these things.
I also have a question. Thanks a lot for the presentation, and you have very well explained for an experimental physicist what are the steps that must be
At least in my opinion.
yes, sure. From the knowledge of the physical phenomenon to the knowledge of the apparatus, the knowledge of the software. So from the point of view of a student, which of these steps is the most difficult to achieve? And if you have any suggestion for a teacher how to make their life easier.
Okay, this is a very tough question. Okay, I think the most difficult part of this is when the student understands that he needs to exploit simultaneously everything that he learned in the past. Because usually a student is get to use to follow a lecture, attend the course, and give the exam just focused on this, on that topic. And when they arrive in the laboratory and we ask them, okay, about particle physics, quantum mechanics, electronics, software, they are a little bit, they lose their reference frame, and this is not normal. I think this is the most important part of, the most difficult part of the job. The second, excuse me, Simona, the second one is, the second question? Okay. As a teacher, I think the most helpful thing is to sit down with them. As I try to explain, they have a problem. This is what I do daily with my PhD student, with my postdocs. Usually you have some problems, you have some distribution, some plots, some graph. And the most educational things that you can do and to solve, to help them to find the way to solve, to find where is the mistake, so to understand what the plots, the distribution is trying to telling you. And this is the most important teaching aspect of this job. Okay, it's very difficult because sometimes it's not clear that when you do this kind of real measurement, even if you know everything, because every year, for instance, you repeat this measurement, sometimes students made something which is very complicated and it's very hard to debug the system to understand where is the mistake and the bug. This happens not only at this level, but also at very high level when we try to do our high precision measurement to try to improve our knowledge of fundamental interactions.
Thank you, and let's get an applause for our speaker.
Many thanks.
So we use some break time, so let's enjoy the rest of the break and we are going to start the next session.
Okay. Okay, perfect. So let's start our second session about EELISA Communities. My pleasure to present Aslı Çalkıvik. She will talk about engineering meet the social sciences, the possibilities and challenges for interdisciplinary learning and collaboration. Thank you.
Thank you, Simona. Morning, everyone. Buenos dias. Buongiorno. So I'm Aslı. I'm not an engineer. Okay, sorry. I'm not used to talking to the mic. I can generally shout a lot, so I'm not used to talking to the microphone. So good morning, everyone. I'm Aslı. I'm a PhD in political science, specializing in international relations and political philosophy. And in my work, I combine the two. So I have nothing to do with engineering, except the fact that I teach at an engineering university, a very important one and a very old established one, Istanbul Technical University. And I've had the distinct pleasure to be a part of the EELISA project, which made me feel at home at İTÜ, a home for engineers. I felt at home as a social scientist at İTÜ, thanks to EELISA. And today I would like to talk about a project that we have been working on with my colleagues at UPM in Madrid and UPB at Bucharest. So in the first EELISA call, we as a community based in Madrid, we organized a workshop and we called it Emergency Workshop for Engineers, a social science emergency workshop for engineers. And we convened that workshop in Madrid at the end of March. And I will talk, in my talk, I will talk a little bit about that, our experience, and what we tried to do. And thankfully, we also made another second proposal in the second call, and we kind of expanded that project, and we're going to now do that organize that at ITÜ, this time in Istanbul. And our new project that we're currently working on is entitled, should be engineering that is up to the task. There was some problems with the slides, so it's just that it's up to the task. So it should be engineering that is up to the task, developing interdisciplinary techno solutions to meet social challenges. So my talk will basically be based on, as someone coming from the social sciences, the possibilities and challenges for interdisciplinary collaboration that EELISA is trying to support and motivate. And yeah, so that will be the general. But I said I should do a little interregnum and kind of talk about a little bit, I shouldn't call it a caveat, but kind of like start exploring some of the ideas I think that is motivating our presence here, our gathering, our conversations here. One thing that I want to highlight, I put engineerings on my title, and I checked it a couple of times, whether it was okay to say engineerings in English, right? And it said no, there's just single word engineering. And if you want to say it in the plural, you kind of define it. Computer engineering, blah, blah, engineering. But I want to highlight, so even though I can't use the word in English, I want to highlight that there are different engineerings and there are different social sciences, right? So as engineers, I'm sure you do not agree on a lot of things among each other, right? Just like the social scientists, we don't necessarily agree on a lot of things as social scientists. There are certain things we agree upon, but we also disagree, especially that's why I want to highlight that they're not only interdisciplinary disagreements that we need to take into account when we talk about interdisciplinary research-based learning. They're not only interdisciplinary disagreements, they're also intradisciplinary disagreements. Also in the social scientists, among positivists and post-positivists, are scholars who want to imitate the natural sciences when they're doing research on society, and those of us who think that natural sciences and methods of natural sciences lack the necessary methods to understand a complex thing like society and how it works. So there are lots of disagreements among us. Let's not lose sight of that, right? So I was also thinking, as I was thinking about, and I put Gabriel Pinto's representation as a note to me. It shouldn't appear there, but that's okay. After his presentation, we were having conversation with some colleagues, and the notion emerged that how do we use Gabriel's presentation ideas of what they're doing with chemistry. I don't know if you guys recall the presentation, and how to kind of develop that for a more global perspective. So I was thinking about that comment, and when we think about research-based learning, can we develop a global perspective, I think, is another question we need to think about. In other words, global in the sense that a method that could be applied everywhere, that could be replicated, et cetera, right? To make it a universal method. I mean, that's the aim of the sciences, but as I will also explore in my presentation, even the sciences is not as universal as it claims to be, right? Simona, are you keeping track? I'm a very time-conscious person. Okay, so let's go. The point that I want to start at, as a social science, by the way, I used to be an engineer. Like, I studied computer engineering for about 4 years at ITÜ. Right? And I quit because I thought that that world of engineers was not fit for me because engineers didn't like ambivalences, right? They didn't like the gray areas. They're like, it's either white or black, right? At some point you have to decide. Where I thought ambivalences, unknowns, disagreements are the drivers of change, right? Not closures, not agreements, but disagreements, conflicts. In other words, politics, right? Politics is about disagreements. If we all agreed, there would be no politics, right? Somebody would say something is right and everybody would agree. Well, there's no politics there. So that's why I kind of moved away from engineering in the sense that that world kind of didn't really capture the way I see the world. Anyhow, so when I say things, the reason I pointed this out was that I came from being an engineer and transformed into a social scientist. I still carry that part of mathematician, scientist in me. I don't forget that. So please do hear my comments as a former engineer and a now social scientist. One other thing that I want to highlight is it's interesting to see with some of the ideas that are being shared and we talk about here is this notion of interdisciplinarity, this notion of not merely focusing on your little tiny dent, but taking a more global perspective. And of course, I was thinking, and also someone's comment, I can't remember who the name of the presenter, my apologies, but he was talking about the method of Galileo. I mean, that kind of, that whole notion of interdisciplinarity that I think we need to dwell on. Right? And that reminded me of the humanities research and humanities studies. And the reason I put this picture is like the famous picture by Hans Holbein. You know, it's like kind of symbol of Renaissance, right? These gentlemen ambassadors, right? What they depict is on this, if you can see on the table, these, you have the music, you have astronomy, and you have sort of geography, all kinds of disciplines, right, that are being laid down on the table. That's kind of like symbolizes the education of humanities, right? A uomo universale. Right? That was before, with modernity, we have the disciplines that as we know of today, right? Disciplines like social science disciplines, disciplines that, like the ones that you are dwelling in. So everybody, like the world with modernity has been cut up into pieces, right? And we all each focus on one piece, right? Before modernity, before the way in which modernity approached knowledge production, right? The world was seen as one, right? And if you are a scientist like Leonardo, you were also a painter. You were also an architect. You were also, a scientist, right? So the arts and the scientists were not seen as separate. Right? Is that what we're trying to do when we talk about interdisciplinary? So we need to, I think about that as well. That's very good. Okay, sorry. This is, I still have a lot. So let me talk a little bit about the workshop that we did. And we thought, like, the reason we want to do that was I am being approached by my engineering friends about the fact that, oh, we need to hear from the social scientists, their perspectives. We're doing this biomedical research. We need to know more about ethics, etc. It's usually approached as something that is added on to existing research. Whereas as a social scientist, when you look at it, it's not the politics or the social aspects of your research is constitutive of what you're doing, right? It shapes what you're doing from the beginning. So you can't just add social science. So that was the reason I put question was like, okay, check yourself, but this is the old slide, so sorry. So we did a 2 days long hands-on workshop at Madrid. And we had over 30 students and faculty members attending the workshop. And we had some lectures in the mornings, and then so that we could provide the students with certain conceptual tools, questions, etc. And then our students carried out some group activities in the afternoon. These are some pictures from those meetings. It was really wonderful, and all students did certain projects with the insight they gained. So they all had to come up with some projects. Okay, since I am running out of time, I'm going very quickly. Just as a perhaps rounding up, I was thinking, like, how can we, as social scientists and engineers, have conversations as we think about interdisciplinarity, as we think about research-based learning, as we think about research that has a social impact, right? That's what we're trying to do. We're trying to do research with social impact. And I was thinking, well, how do if a social scientist and an engineer walked into a bar, what would happen? Right? What I would say as a social scientist. And this is my good friend Cristina from UPM. As we were initially working on this workshop with her, and I really like using this slide because I think it really depicts this, a slide that she had prepared. And I really think that it depicts. So as coming from different disciplines, we look at the same world, but our disciplines tell us to ask very different questions, right? So conversations are not enough. So as an engineer, you look at the same thing, you name the problem differently, right? As an anthropologist, and Dulcinea is an anthropologist, so, or as a political scientist, which I am, we look at the same thing and we phrase our problems very differently. So although we look at this, we think that we look at the same world, we see very different worlds, right? That's one thing. The other thing that I want to highlight, and we highlighted in the workshop, and I don't want any of my engineering friends and students to ever forget, is the context of all the research that we are doing. Right? We're not devoid of all the global political, we need to take into account of the global political sociology, global political economy of our research, of our thinking. Right? And the reason I put this up is because we generally talk about AI, ChatGPT, et cetera, but you might be exceptions, but very few of my students actually knew that in the development of ChatGPT, there was really almost slave labor being used, right? And this is, you can find more about that news on it was a Times magazine investigation, which kind of showed how, demonstrated how Kenyan workers worked less than $2 to develop the ChatGPT. So we hardly ever hear that side. So we need to take into account the global context of our research and of our thinking. So, and see that our research is inescapably social, political, and have ethical aspects. Right? I don't have enough time, but I will just, if you want to do in the Q&A, perhaps I can elaborate. So one thing that keeps coming at me and this thinking about our research-based learning was the importance of, and a few speakers yesterday highlighted it, the importance of being critical, the importance of being creative, the importance of being curious, right? These were all highlighted. But what do they actually mean, right? So for me, for instance, critical thinking is very different from what a critical thinking was defined yesterday as something that could be validated and verified. That is not, for me, critical thinking, because it actually confirms common sense, just merely verifying and validating. So I put this little quote because I really like it. I think importance of being critical and curious and creative is about asking good questions, right? Not necessarily having the right answers immediately, but asking good questions. And I like this quote from Gilles Deleuze, a famous French philosopher, and I'll just quickly read it. We are wrong to believe that the true and the false can only be brought to bear on the solutions, that they only begin with solution. This prejudice goes back to childhood, he says, to the classroom. It's only the school teacher who poses the problems. The pupil's task is to discover the solutions. In this way, we're kept in a kind of slavery. The true freedom, Deleuze says, lies in the power to decide, to constitute the problems themselves. So I think research basing is encouraging students to ask good questions, right? Even if they don't have the answers. I was going to talk about the right to frame, and I kind of like, oh, these could be like the rights to fail, the rights to make a mistake, right? We hardly talk about failure in research. All the pictures that I've been seeing in yesterday's presentation, it's about happy people doing research and ending with a happy ending. But the world doesn't work like that, right? There are lots of failures on the way that we need to notify. And the right to frame was basically the notion that we should be ready to sort of forget our investment in a certain project and to be able to begin anew. What do I mean by that? And I have a short example, if I have time, less than 30 seconds. No, 1 minute perhaps, not 30 seconds. But this wonderful example about how research was reframed, right? There was this this is something that I read in one of Sheila Hasanov's articles, so it's not mine. So she was quoting this research being done in India to prevent certain diseases that was, that you get it from infections from water. So they try to sanitize the water, right? And they encourage the people there to use this sanitation thing. And people don't use it, right? And it just doesn't work. They have the best medicine, but nobody's using it, right? And the researchers are willing to sort of let go of what they have found in the best medicine, and they instead look at the cultural aspect of that society. And what they find out is that women are wearing skirts, right? And they use the skirts to sort of distill the water. And it is more effective, right, to actually prevent the disease. Right? So reframing, in other words, sort of letting go of your investments, which I know a lot of us, you will be saying, you're engineers, and I'm done, you'll be like, oh, there's all that money that is being invested in this. How can I let go of that? I am aware of that. But I think sticking with what doesn't work, right, sticking with the wrong questions, right, wrong solutions is actually worse and more expensive than asking a question anew. So thank you and for your patience.
Thanks a lot, Aslı. Is there any question for Aslı? Yes, please.
Yeah, thank you for your presentation. I'm not sure it is a good question, but I would like to ask, what is a good question? How do you define it? Thank you.
I can't define a good question, right? But I think because it depends on context, right? We can't, that's why one thing that we need to be aware of is that perhaps it's not necessarily within the given framework, right? Within perhaps a good question is not something, I will say what it is not. Right? I can't define for all things that what constitutes the best question or the good question or whatever. But one thing that I know is that something that doesn't confirm common sense, that goes against the grain, right? That kind of defies what is being told as the way to do things, perhaps as being too radical, but kind of like be willing to challenge common sense. I think what constitutes a good question, right? But I can't speak for all times, all places, all issues, but something that goes against the grain, I guess, right? Thank you.
Thanks a lot. Let's thank the speaker again, and we have to move to the next talk. So I ask Òscar for his presentation, a presentation which is titled Bringing Together University, Industry.
So thank you. Yeah, it's
yes.
that one. Yeah.
So bringing together university, industry, and territory in an educational environment through EELISA Communities activities.
Is this one, but you need to go to the first. So this is the number 25. No, it's this one, but you need to go to this one. So anyway, so meanwhile, because that one was the 20 slides. So thank you for having us, and I'm very happy. Very, very, very happy to be here and as well to be before our colleague, because without knowing each other, you just made a very nice introduction, a theoretical introduction of a lot of aspects that we are going to, or I want to present today. For example, this idea of relearning that I think is really important as well, because of the three cases that I'm going to show you briefly are going to be about this, about relearning, about disagreements, about as well the right to fail, and as well this idea of arts and science, and how arts and science, as you mentioned at the beginning, was something together, and how since the 19th century we separated. So this idea of shaping ideas and education of the humanities and how we are connected, so it's very important. So my name is Òscar Santos. I'm from the UPM in Madrid. I'm an associate director for Student Affairs, Innovation and Entrepreneurship at the School of Engineering and Industrial Design. So we are located, our school, in the downtown Madrid, and all the examples, or some of the examples that you're going to see, are related how is the role of our university, our school, with the industry and as well with the territory. Okay? So the frame of these three cases that I'm going to show you are connected and related to our community, so industrial design for human, that basically we are addressing, or we try to address real social issues with territory, and as well thinking about the educational environment, okay? This idea of community is to try as well to find different kind of demo sites. So we are now on the process to trying to find places in EELISA Alliance to try to develop these kind of cases and scenarios. We have a social vision to empower the human beings, and as well we have different as well inter or intra-disciplinary kind of ideas and disciplines in order to impact the society. We have 5 projects, as you can see as well, and as well each project has a mission, one related to mechatronics system design, one related to food production, process design, and we have, for example, one of the cases that we are going to see very briefly, the Bio at CV Lab. Then we have the third project to empower people in their neighborhoods related to education, culture, and engineering. And we are part of the DESIS network in designing social innovation. Then we have the fourth project, educational and design. So they have these processes designed in network, diseño en red, network designed. We do exhibitions in Madrid, and as well collaboration with different universities from the area. And the fifth project, design-based energy efficiency technology. And we have these courses from the EELISA and as well from our incubator in China, in Shanghai, introduction for social entrepreneurships. So this is kind of the background of our community and as well the work projects that we are doing. And as you can see, for example, here, we have our community, and then we have the different projects related to the sustainability, service learning approach, entrepreneurship, and STEM and mediation, okay? Because we do believe that intercultural community professional mediation it's an essential part for any engineering to try to find a mapping and a prototyping and a right diagnosis of any kind of project. So the first project that we are going to talk is is part of the Innovation and Science Week, okay? And always we try with that project, okay, related to BioLab at CD, is kind of facilitate the exploration and the study of the biological science in terms of nanocellulose, okay? That's a workshop that we do with primary and children that manufacture the polymer used on nanocellulose, and we're trying to explore the different possibilities and as well to bring and create in terms of how to transform these kind of materials. So we do these workshops in a week, okay, and try to connect other education to our school, okay. Basically, this lab is working in the organism cultivation and the cooking as well recipes, and as well we have a 3D printing printer that works on that. And as well, we work in different kind of activities, okay? So the activities, for example, that you have seen are related to awareness of rising activities with children. So as well, in order to create kind of these interactive demonstrations and hands-on activity, okay? We work as well, these activities are made by a lot of students' internship, and as well to try to see different ways to apply fabrication, materials, production, and as well lead and mentor by students, okay? So we work a lot on that as well our students from the different degrees are kind of protagonists of the action. Okay, then we have the second case on the second activity that I divided like 2 hackathons, one more local and another international scenarios with 3 EELISA communities with liderated by egalitarian societies, opportunity for everyone, then the Tech Diplomacy International Cooperation Community, and of course our community, Industrial Design for Human. And I want to mention that because what we try to do, there was the local one, the sustainable communities that we did in Madrid, and this one was that we collaborate in Bucharest. That's important because we try, and that's one of the things that amazed me about the Alliance, the EELISA Alliance, that we met together with different expertise, different disciplines. So we have professors and researchers from education, social science, then of course engineering, computer science, as well cultural studies, and we work together in order to develop a topic. And that's one of this collective experience through design thinking was great, and we are trying to repeat it next fall. Okay, so this is an example, and we can discuss it then if you want, how we can connect different disciplines and different approaches through one topic, okay, and through one methodology, okay. So we did it the first one in Madrid, okay, and as well working with different companies and different industries, so what we call the stakeholders, okay. There are these companies, so we have a big one like Sika or Accenture, okay, on Ormazabal, but then we have tiny ones that are part of our collaboration. The idea is that the company mentor, okay, the projects, and mentor as well the developing of the idea. They present some of the goals, and then the pursuit, okay, the mentoring with our students. The idea of this is that we have, before the hackathon, we have the training. So we have some workshops, some lectures, in order that the students get the skills to develop somehow the tools in order to do the hackathon. Okay, so there are kind of two perspectives, two ways of connect communities, companies, territory, and as well university in order, in that case, through design thinking. Okay, and here you have some examples. And last but not least, okay, so we have the project Es Nuestro, it's our, that's a community-based service learning and mediation project. The idea is to connect and to bridge engineering, arts, and communities, okay? So this project have specific actions and collaboration activities between students, professors, stakeholders, and as well neighbors from our territory. As I was mentioning at the beginning of my presentation, so we are in downtown Madrid, so we are in a very gentrification, touristification kind of neighborhood and territory that is changing and losing a lot of population, but at the same time is a very migrated neighborhood and territory. So with this project, we go to the squares and to the public places with our students from industrial design and engineering, you know, and as well we have students from architecture and as well from other disciplines, chemistry, in order to ask questions. This idea as well to interview, ask to the population how they can improve the neighborhood and how they can especially work with different solutions, try to find different solutions for the neighborhood. Okay, so we work with the community, we work with the different population through different weeks, like 3 months. And what we try to do following the Sustainable Development Goal 11, that's so trying to get alliance with the communities and to trying to find a more sustainable city, is to develop different pilot experiences. Okay, so we developed, after working with the community, we work with different pilot experiences. So here you have some examples. So here we have, they are measuring the quality of the water of the fountain with the chemistry students. Here they are working with the kids and as well trying to like working with the different polymers and as well how to reuse the plastics, and as well they are doing and working on the different labs. Okay, so I think I'm going to stop here. So because we have as well, these are different another activity that we do in Es Nuestro, so the step R. But I think in order to summarize, so these are some of the key aspects that we work in these 3 projects. So first, to try to find collaborative environments, then try to combine the community plus the ethics using the learning by doing methodology. Then this idea of engineering, technology, and design and how is integrated, and of course the service learning, and then this goal of how we connect with the territory, how we connect with the society. Okay, these are the Sustainable Development Goals that we follow. These are some of examples of the designs that are doing the students for the community. So 3 main goals that I would like to propose you. So when we work with in our classes, when we are working with our final thesis works, we are working in different kind of subjects and projects. So how we to transform the cities and communities through the development, and how we try to be more flexible and sustainable. How we develop digitalization process, and as well for citizens and for migrated people, and how we integrate the leisure of the life of city, okay? And the continuity, okay? How we generate joint projects around sustainability, how we mapping somehow, and how we do the diagnose through these activities, and as well how we incorporate as well research projects with service learning, and as well how to think and balance with the future challenge here in EELISA. Okay, so to finalize, because sometimes to develop this is kind of difficult, so if we can move, no, I can move back, yeah. No, can you go outside, because I think we have the video. I would like to show you at least 1 minute of the video of Es Nuestro, the third project, so you can see how the students from engineering and architecture, they go to the squares with the community and trying to find goals and projects. Yeah, you can.
¿Qué necesitan las personas que habitan Lavapiés y Embajadores en términos de sostenibilidad?
Bienvenidos
y
bienvenidas
a su programa favorito, El Barrio es Nuestro.
Es un proyecto que busca romper barreras entre el arte y la ciencia desde una perspectiva de diversidad y participación ciudadana.
Vamos a intentar deconstruir o repensar estas terminologías, ¿no? Sostenibilidad.
Datos a partir de las experiencias y las vivencias de las personas.
Bienvenidas a la ETSIDI, que es la Escuela Técnica Superior de Ingeniería y Diseño Industrial.
Tiene que primar, sobre todo en un barrio sostenible, el derecho a la movilidad humana, y para ello hay que hablar de vivienda, educación y sanidad.
La Plaza del Sol de mi pueblo, de Alcorcón.
Objetivos.
Esto está llena de negros, ¿eh?
They are playing, they are going to the community, and this is related and connected to the intercultural and artistic mediation, but at the same time they are going through the squares and they are then developing this mapping diagnosis in order to try to solve and to at least ask and get questions from the community. So thank you.
Thank you, Òscar. We have time for a quick question.
Thank you, Òscar. I have a question. Do students, are these, do they take special courses to be a part of these projects, or is it required part of the curriculum? And thank you for the presentation. And that's a good way to ask good questions, so if that's a live. But thank you. So is this obligatory, or are they elective courses? How do you do it?
So I gave that's the reason I showed the three examples very briefly, and that's the reason I wanted to show, because there are different, each example has different scenario, okay? We have an optional, like what we call actividad acreditable, so it's a kind of an optional activity that they get some credits, okay? That calls engineering, arts, and society. And if they are participating in any of these three activities, okay, they could get some credits, okay? That's the kind of the transversal kind of aspect. However, in some of the activities, they are connected to the final thesis project, okay? So for example, on the second one, part of the first one and the third one, they are connected with that. Then the first one, the students are part of the lab, and as well are part of that lab. So that's one of the activities connected to that lab, and as well the different associations and clubs that we have at the university are connected as well with the first activity. So basically we have the three options. Yeah, actually 4 options. So related to the final thesis work, related to one's official subject, related with one non-official, let's say, subject, and as well connected to the clubs and association. Okay, was that? And the final thesis, yeah, exactly, for the final thesis. Yeah.
Yes, but I'm sorry, we have to move on. We are already quite late. Thanks again to Òscar. And let's move, thank you. Let's move to the presentation by Andrea Tellini and Alicia Canton-Pire, activities of the EELISA Community Series.
So thank you very much. Thank you very much for attending. Special thanks for the organization, the local organizers, but also the non-local organizers that gave us the opportunity to present the activities of our community, which is named S-Series, and I will try to explain what we are doing through the name and through our logo that you can see here. So S-Series is an acronym. Let's start with the name. And the acronym means Science for Sustainably Envisioning Reality and Information for an Engaged Society. And so this acronym encloses what is our mission and what are our main lines of action that I will now briefly explain. And then I will focus on the activities that we have done and the activities that are ongoing and the future activities. So we will try to give a very concrete approach to explain what we are doing. And apart from the acronym, the name S-Series is a word game that recall the mathematical concept of series, because I have to say that both of us are mathematicians. And so we like that because it means that the sum of a lot of small pieces can give actually a very big result. And this is what we are trying to do with our activities. So the mission of our community is using science meant in a very broad sense, to use it as a transversal instrument to achieve a sustainable world. So, and we will see how we try to do that, and our activities are specifically related to these SDGs that we have put there. So the 3 lines of actions of our community are enriching scientific culture with art, something that has already appeared in other presentations, promoting open citizen science, and apply critical thinking to combat disinformation. So we will see how these 3 lines appear in the several activities that we are going to present now. But before that, let's go to the people. Our coordinators are Maria Jesus Vázquez Gallo and Maria Balbero Lignan from UPM. And they do a very great job coordinating the 49 members of S-Series. We mainly belong to UPM from 9 of the schools, faculties at UPM, but there are also members from external universities. And our international partners from the EELISA community are SNS, UPB, FAU, ENPC Paritech, and BME. And we will see how, in which activities they are specifically involved. So here is the list of the activities that we are going to present, and now instead of reading them, I just want to mention that 3 of them were selected in the first EELISA joint call, and we actually concluded these activities with a final workshop that took place in the second half of April in Madrid. So let's start with the first one, Arts and Science Competition. So this was actually an activity that was already done in Italy, organized by the National Institute of Nuclear Physics in collaboration with CERN. And it consisted of secondary school student teams that were mentored by university students, and that did, in groups, say they prepared a presentation on a scientific concept, but the way to convey this explanation was through art. So this was arts and science. And so the main aim was stimulating creative ways to disseminate science for the high school students, and for the university mentors, it was the goal was developing mentoring and group leading skills for them. So here there are 3 examples. So here we have, for example, a painting about Schrödinger's cat paradox. So apart from the explanation of the paradox, this girl from high school did this painting to help conveying, and then here we have some screenshots of 2 videos that students did about some other mathematical concept, the geometric sequence, or this surface which is called oloid and is used also in engineering applications because of its properties. So other activities related to high school students for dissemination of science and engagement activities of university students are an open access journal which is called Mathematical Thinking Journal. Actually, the name is in Spanish is Piensa, Think, Pensamiento Matemático, sorry, Mathematical Thinking. And it is related to many aspects, so it includes research, so the research articles can be published, teaching experience, history of mathematics, mathematical games, so it has a very broad spectrum for contribution, and it is open to contribution, so if you want to participate, you can find information. I will give later how to get in contact with them. And it is important to mention that it is an open access journal. Then, in the School of Civil Engineering at UPM, there is this mathematical museum, which is it is meant to be as a hands-on workshop museum, where students from high school or families go and mentored either by professors of UPM, but also mentored by UPM students. So the people that attend the sessions are proposed some mathematical reasoning games or logic problems, so also trying to stimulate in a playful way the reasoning skill of the students, of high school students. So passing to a third activity that was organized in the framework of the Science Week of the region of Madrid, and specifically is a Research and Development Agency. So this activity was done in collaboration with the Architecture School and was aimed for high school students, again mentored by UPM students, to see how the concept of ruled surfaces, which is a geometrical concept, can be used in architecture. So first of all, professors from UPM gave a talk about ruled surfaces, so giving examples and how they are used in architecture. So it may recall of some building, for example. Then students constructed the ruled surfaces. So this is the process, and this is the final result to see how the students, the result that the students got at the end of the activity. So.
We also had what is called citizen labs, called Experimenta Mates. A citizen lab is just a collaborative network done with the community. So some institution promotes an idea. In this case, we had noticed that the perception of mathematics is really negative among most of the society, and we wanted to fix that. So we started a citizen lab and asked for brainstormer ideas of how we can fix that, and citizens give ideas. Those are the promoters. And groups of citizens join those ideas and give some structure and solutions how to solve this issue. For example, there was a person that worked in a library, and she proposed people to write short stories about mathematics and what they felt about them or what they thought about mathematics, and those short stories were told at the library. Another example, this was promoted by architects, was the design of acoustic panels to use using recycled paper. And even a company has got involved in this project, and Athens course is taking on this idea. And they're actually doing these acoustic panels on some rooms in the classrooms at the UPM. Also, we wanted to raise awareness about how easily misinformation and disinformation is spread through social networks. And so we decided to do it from a playful point of view. And we organized a championship to increase this awareness of disinformation. To do so, we first started with a crowdsourcing of a database of pieces of news that had to be graded as false, half-true, misleading, or true, and they have to be checked by a reliable source. And once we had this database, we started the championship, where students from different universities, UPM, FAU, EMPC, Paris Tech, and BME, participated. And the process was a little bit like this. We gave a headline, like this one, Rats Can Compose Music. This research help shed light on how brains evolve to perceive rhythm, and then a little summary of what the piece of news said. And from this information, they had to decide whether the piece of news was true, half-true, misleading, or false, and give a reason why they gave that grade to the piece of news. No. And then we had another activity, which is a MOOC, course in engineering architecture. It is a MOOC created by 9 faculty members of different Spanish universities, not only UPM. And it is a very mathematical course. It's not, I'm not going to lie to you. I mean, it has a very mathematical viewpoint approaching to course, but how they can be used for industrial design, road safety, and construction. So here on the right, we have a curve, which is called clotoid, that gives the transition from straight stretches on a road to a curved road with being safe. So you wouldn't go out of the road with your car when you move on that curve. Or on the other, we see a car, and it's done with splines, which is actually the curves that are used in CAD computer designs. In this course, we had so far with more than 500 participants, 16 the last 3 months, and it's a long curve. This course is 45 hours.
So now, the last activity that we present is Math for SDGs, Mathematical Approaches for SDGs, and it is a research-based learning activity that actually, so it fits in the other part of this symposium, where a group of math students from different EELISA institutions, specifically SNS, UPM, and UPB, worked first online on projects, and later I will explain what type of projects we proposed to them. And so this first part online was under the supervision of a faculty member, and then we organized this final face-to-face presentation of the project in the frame of the final workshop of the final first joint call that I was talking before. So these actually are pictures taken from the presentations of the students. And so the kind of projects that we proposed were, as the title of this activity says, is to show how mathematics can be used to tackle some of the SDGs. So first of all, for example, how the dynamics of populations which are affected by climate change can be studied. For example, in this map of Great Britain, we see how a species of butterflies first was located in the south of Great Britain and then moved toward the north due to the climate change. And so seeing if the species can adapt to this change in its environment can be described by mathematical equations. So another project was related on the pricing of financial products, taking into account the risk of due to climate change, and the last one was again population dynamics model, but related to the use of natural resources, like specifically deforestation. So just now, let's go to what we are doing now and what we plan to do. So ongoing projects, one is related again to arts and science, and is math and dance, that will actually be presented in the first EELISA International Conference in Bucharest in October, and is meant to convey some mathematical concepts like shapes or graphs through dance. Then we plan to organize a new international edition of the Citizen Lab, now an international one in the framework either of Athens or also EELISA. Then regarding the disinformation activity, there is an app which is being designed together with a startup company. And the purpose is to create a game. So with this mechanism of news, detecting if they are false, misleading, true, or half true. And so see if, for example, if I detect a news which is false as a true one, and I share that news on the internet, I'm doing something bad, because I'm propagating fake news. And so the app will try to simulate this kind of behavior. And then there is a project on science and tech for heritage, where a visualization method which are usually used for civil works, like to track roads, are being used in the case of a bridge from the Roman times in Galice, in the northwest west of Spain. And so these images are taken to know how the bridge exactly was. So to reconstruct the bridge and also to help with its restoration. So passing to the second joint call, we have talked of the activities that we did in the first joint call. And now we go to the second one. And the second one, we have two activities that have been financed with people participating from our communities and other EELISA partners. So one is women's workshop on multidisciplinary education students' needs. So to analyze how to increase the participation of girls and to increase the inclusiveness and diversity in STEM degrees. So some workshop involving also external agents will be organized. And then the new version of Math for SDGs will be Math for MPs, for multidisciplinary projects, where now math students with students of other disciplines, engineering or other disciplines in other universities, will work together on some projects. And then back to the EELISA International Conference, we apart from presenting math and dance, we also plan to organize a parallel section on the role of mathematics in the EELISA University, both as a teaching aspect in collaboration with other disciplines in the EELISA institutions, and also from the research point of view. And just now to conclude, these are the links where you can find detailed information about our activities. The first one is one located at UPM with all the activities, and the second one is the link on the part of the EELISA website dedicated to communities, and there you can also follow us to be updated of new activities, and if you want also you can join our community. And so our take-home message is that if you like our activities, if you like our mission, our line of action, try to interact with us, collaborate with us, create with us, and as our mission says, engage with us. So thank you very much for your attention. And if you wanted to know, if you wonder what the news about the rats was misleading, and this is the source, an article from Science. So thank you very much for your attention.
Thank you, Andrea. Thank you, Andrea and Alicia. Any question for them? Consideration, comment? I have one. So I just it's a consideration. I was just noticing that several of your initiatives are, to me, strictly related to the RBL approaches. So I'm thinking about math and science, math and dance, and or art and science. And I think that this could be also a possible path to help students to learn some disciplines that are quite difficult, as math, as physics. I don't know if it was also in your intention just to also approach the learning curve of the students with this kind of initiatives.
Maybe at the level. Maybe at the level of high school students, especially. So because we act on these kind of activities, especially with high school students, and actually, their contribution were the paintings, the videos that they did were very impressive. So we hope that with that, this playful and transversal approach to science could stimulate the participation also towards STEM's degrees. Yeah, definitely. Thanks.
Okay, so we can now have the coffee break. There is just a small change in the program, but we prefer to have the coffee break here, so we reconvene in 15 minutes. And okay, so the coffee break is in the inner courtyard. On the left, you go down to the steps and you will find the coffee break. Thank you. Okay, so we can start again, and we now have. Hi, Esteban. Can you see me? Okay. So welcome back. We start now with we have an online presentation by Esteban González Guardia, and he's giving a talk titled "Creating a Culture of Openness." 15 minutes, so I will tell you when 10 minutes are passed. Thank you.
Okay, perfect. Do you hear me well? Yeah?
I hear you, yes.
Yeah, perfect. So, thank you. I want to thank to the organizer for these remote sessions. I'm so sorry for not being with you today, okay, but it was not possible. So today I'm going to talk about EELISA community, that is open science community. So I'm one of the coordinators, Esteban González. I'm from UPM. And the other coordinator is Burju. She's working in the I2. Okay. So regarding the openness, okay, we have a different. The open science is quite important in, as you know, in many organizations. There's a priority, for example, for UNESCO, but also it's very, very relevant in case of the European Commission and also in European projects. So probably most of you are deal with European projects, and you know that you have to publish your, we can say, your research output, because when we think about open, it is not only about papers, it's also about data, software, and other kind of research artifacts. Okay, so it's very important to know how to publish your research artifacts open. Okay, for example, I'm working in UPM, and I'm also I'm a facilitator of the open science community inside of UPM, and we have many questions about how to publish all these research artifacts as open. Okay. And I think the importance of this community is basically to expand, to extend this message about openness to other EELISA communities. So inside of our EELISA, of our open science community, we have different objectives. So basically, is from our perspective is okay. We try to collaborate with other EELISA communities to show them how to publish all these, we can say, resources or outputs of their research by open. Okay, so this is one of our priorities inside of the objectives of the open science community. Another objective in our community is to share experiences. We believe that it's really important to create like a framework where everybody can share the experience they have with publications, data, software, etc. Okay, and I think this open science community can play a role in it. How we plan to do it? We are in communication with one of the projects in EELISA. This is EELISA Innocore. Basically, we are in coordination with Work Package 3 inside of this project, and our plan is to like extend all the results that this project is going to produce to the rest of the EELISA communities. So how can it benefit me? Because you say, okay, sometimes when you deal with open, you say, oh, it's very difficult to publish. For example, this paper in open, I don't know how to do it, etc. So yes, it will take a little bit of extra effort to publish at open, but I think the reward is more greater. Okay, just remember, for example, I'm from the machine learning domain. Okay, and well, we are usually use data set from other researchers. Okay, so for us, it's really important to reuse not only the data, the software for other person. So this is the things we are trying to do in our community. So basically, what are your benefits of participating in this open science community? So basically, it's develop open science skills. As you remember, imagine that you have to do a data management plan that is very famous in the European project context. Okay, well, you can learn how to do it inside of our community. And also, I think you can be very more visible in EELISA institutions, or even you can share your open science experiences with other participants. And I have to say that inside of our in our community, we have different roles. We have librarians, also we have technicians, software engineers, data managers, students, associated professors, lecturers, etc. Okay, so we have a very good diversity inside of our community. And of course, you can participate in open science activities, etc. Okay, so I think some kind, be part of the community can give you some open science skills that can be used maybe in the future. So I think that the way to evaluate in universities is changing, and there is some initiatives that are incorporating open science indicators to evaluate professors and lecturers. Okay, so I think it will be very interesting to know how to deal with that. Okay. So during this year, because we are a young community, so during this last year, we have participated in different activities. One of them is a knowledge bites. Knowledge bites are like sessions, small sessions, very informal meetings, okay, mainly with the students, to give some knowledge about some specific domains or themes. In our case, we use this special session, and we organize one per month approximately, okay, to train students about how to publish papers in open, how to deal with the EOS services. EOS is the European Open Science Cloud. For example, how to publish data, how to publish software, etc. So this is like a training session for students mainly, okay, but researchers can participate also. Okay? It is not only close to the students. And also, we participate in the International Open Access Week, of course. When we talk about openness, we have to think about open access, okay, for sure. And remember, when we talk about open access, it's not only to publish some specific research in any place. You have to do it in a proper way, okay? And you have to take care that this research must have a proper license. So, for example, in the knowledge base session, we show how to assign a proper access, a proper license to your research, okay, to make more open, okay. So this is one of the things that we are doing. In this case, for example, in the International Open Access, we organize like approximately 5 sessions, okay, with the different topics. Another activities is participating in international forums, okay, to show the things we are doing in our community, but also in our institutions, and particularly in EELISA. Okay. Also, another approach that we follow, because sometimes we have to, we are learned that it's very difficult to incorporate newcomers to our new members to our community, is to be in contact with other European alliances. I think it's quite important, because sometimes it seems that we work in isolated fields, okay, in isolated boards. And I think in the case of the open science, we have to collaborate between us, okay? So we are in contact with other European alliances like Unite, for example, or Youth. And I have to say that, for example, in collaboration with these alliances, we sent a proposal to the Open Science Fair that is going to be celebrated in Madrid in the next September, I think. Okay, in September. Okay, we plan to organize a workshop. Okay, to be all together and for sharing our experiences regarding with open science in the different universities of these alliances. Okay, I think it's a very good exercise. It could be very useful for all of us. So if you are interested in how can you participate in our community, so you can see right there just below to the slide the URL. So just go to the EELISA Communities and look for Open Science Community. So right now we are 76 members from the different roles. We have different roles, librarians, lecturers, etc. We have organized more than 10 activities, and it's growing. Just tomorrow we have another specific session in Knowledge Bites. Okay, that we are going to talk also about open science. Okay. So if you are interested in participate and be involved in this community, just click on the join button or just send me an email to me, and of course we can share experiences. And finally, what are our future plans? So basically, we are going to continue with activities that we are organizing. Okay, basically collaborating with Knowledge by Session. We have also an open science dictionary in Instagram, okay, that we publish every week, okay, a definition of a concept in open science. And also, we are going to incorporate new training material. So right now there are several European projects that they are working on training material in terms of open science in general, but more specifically in data management. So one of the plans, and we are in contact with them, is to incorporate all this material and be like the channel, okay, to communicate all these new developments in these projects, okay. And also we will continue with organizing periodical meetings between the members and with external people who are interested to participate in the open science community. So that's my presentation. So I'm open to any question you want to make, or thank you.
Thank you. So any question for Esteban? Comment?
So if you are interested,
yes, I can ask you something. So I was just I would like to ask you if you can expand a bit the topic of the advantage of open science. Why I'm asking this? Because I mean I understand from the science point of view it would be a benefit, a strong benefit. But from the point of view of the scientist instead, how can we manage the risk that your idea is? I imagine that you received this question several times. So if you can comment about that. How can I really make sure that the open science is is permitting me to become a leader of my topic, and instead of my idea being exploited by someone else?
But this is my opinion, of course. It's a little bit biased, okay, biased opinion. Okay, but from my perspective, if you make your research open, you are a leader in the case that the people is going to use your research more frequently. So imagine I'm from the research software, I'm a research software engineer, so I'm from the software domain, okay? And if you open your software, okay, you allow to everybody use your software. And if everybody use your software, you will be a leader. That's my opinion. Okay? And you are going to be in a start position, a very good position to ask for funding. Because if the people use your tool, imagine your software, you will get money for that. Okay, for sure. Okay. But well, this is my opinion.
Thank you, thanks a lot. Okay, thanks again, Esteban. We now move to the next talk. So the next talk is by Javier Garcia-Martin, Dario Fernandez Valiente, and Alejandro Barrera Garcia. They are presenting two talks. The first one is titled "We Move Against Energy Poverty," and the second one, "Get Active Against Addiction Problems." So two projects presented by the UPM.
Thank you very much. Okay, I'm Javier Garcia. Okay, this is the... No. Yes, okay. We are going to put together the next two presentations because they are related. To present two experiences to improve our service learning activities that we are developing in our community. First of all, I will give you some brief details about the service learning office at the UPM because they are important for the final conclusions that we are going to show at the end of the presentation. The service learning office was created in 2019. And it depends directly from the Vice Rectorate for Quality and Efficiency. And currently they are working 6 people in this office. But the important matter is some figures, some numbers that we have here. First, the number of projects that have been increasing in the last 3 years, reaching the number of 41 projects this year that are run in this office. Also, it is important the number of external partners, the organizations that are collaborating with this office, reaching the number of 53 external organizations, owning in GIS and so on. And in the middle, we have the number of teachers that are involved in these projects. Currently, the number of teachers is more than 238 teachers. And then we have here the first reflection that is important for our work is the number of people involved. We calculate that more than 1,400 students are participating somehow in these service learning projects, together with the number of teachers that are organizing these activities. Here we saw how these projects are divided into knowledge areas. We can see, this is the number of projects in the last 3 years. We see that the areas more active are architecture and civil engineering. Here in the middle, we have a great variety of engineering branches. And here we have 2 areas that are not specific for engineering, is the physical activity and sport, and the Department of Educational Science. And then we extract from here the second important reflections. The 87% of the projects belongs to technology, engineering, in particular, engineering and architecture. Here we have a brief information about our community. Our community is egalitarian society, but really, to be honest, I think that this is not important because we realize that every day we are working more and more with other communities and other colleagues. For instance, Design for Human, Òscar and Piera are on here, and diplomacy too. What is important is the intense work that we have with our colleagues from Istanbul and Bucharest, all together with communities and our colleagues from these 2 universities are organizing workshops, student competitions, summer schools. But in this project, actually, we are going to focus on the around 10 service learning projects that we develop per year. In particular, we're going to talk about two projects out of these 10 that we are running. And then this presentation is divided into 2 parts. First, we will present two particular projects. The first one about energy poverty and the second one about addiction problems, young people with addiction problems. And these projects will be presented by 2 students who have directly participated in these projects. And then I will come back to extract the lesson that we have learned from this project and the other ones. And finally, to draw what are the future perspectives, the future activities that we are going to develop in order to improve our service learning projects. And then Dario will present the first project.
Okay, so if you can click the link. No, 1 second. Okay, so thank you very much, Javier. Dear participants, my name is Dario Fernandez, and I'm going to present the project that a group of students from Madrid Downs Foundation and also a couple of students of Madrid, of Polytechnic of Madrid, have been working on. So, as you can see here, we focus on energy poverty, but we finally focus on SDG number 7, which I mentioned below, ensure access to affordable, reliable, sustainable, and modern energy for all. So, first of all, I'm going to describe the sections that I have arranged to show you our project. First of all, we are going to start with an introduction. Then we are going to start analyzing what about the problems, the project, our goals, the methodology, the students that have been involved, and also then the results and conclusions. So, as I said, energy poverty is a problem that crosses borders. So, as you can see here in the slide, it's a problem that affects to health, education, society, climate change, and also inequality. So the principal idea, we focus on develop a good practice guide to help these people. So a little more about the problem. First of all, to the people who didn't know what a SDG is, there are like the Sustainable Development Goals. And as I said before, we focus on the SDG number 7, but also during the project, we focus and we start working in the number 4, 10, and 12. So we can find 4 big problems. As I said before, the first problem is that energy poverty deprives people of basic service. I mean, for example, without electricity, it's impossible to refrigerate food or have access to the media. Also, energy poverty is a problem that, as I said before, is affect to health, education, society, climate change, and inequality. It's also a problem that is recognized in the SDGs, and finally, affect to all European Union. I mean, speaking by numbers, around the 11% of the European population have this problem that the energy poverty affect. More or less, it's like 45 million European people. So it's a very big problem for us. So what a little bit more about the project. We want to share with you our project. It's called We Move Against Energy Poverty, and it's a book for that families that have this problem, and it's like a small book or a guide with tips and tools to help these people to save a little bit of money at the end of the month. So we inspire of care of people, society, and the environment. As you can see here, this is my group, and a little bit more of our goals. So in the goals, I want to highlight 4 goals. The first one is to support the care of people, society, and the environment, promote the inclusion of people with disabilities, because we have been working with Madrid Focus Foundation, and also we want to improve learning and engagement for students, develop a methodology based on the curiosity, is what we want to find with RBL today here in Pisa, to focus on curiosity, research, and the last one is to implement group work and cooperation trust. So our methodology is curious. We divide it in 3 big steps. First of all, we want to show you a talk with the student, We think that this is very important because we face the fear that all we have when we are going to trade with people with disabilities, and we think that it's important to have this chat. And then we have like two breaks groups. The first one is theoretical, practical, collaborative groups, and the other one are pedagogic tours. In the first one is like we learn with some games, workshops. I mean, it's like learning by playing. And then in the inclusive pedagogic tours, we focus on talk about facilities. Is more to work on the publication of the guide. So our timeline is like something like this. First of all, we mix the student with the teachers. Then we work together to cooperate, and then finally share with the families, and finally create the guide. So finally, the students involved. We want to, as I said before, to highlight the Madrid in Towns Foundation, and then the students from the Polytechnic of Madrid. So here we have a small video. We want to show you a little bit more of how it works. So finally, can you make bigger? Yes, but I need. Can you click the? Yeah. Okay, thank you. So finally, our results. We want to highlight that during all the project, we have a very good atmosphere. And I only want to highlight three of these results. The first one is the positive participation. Then I want to also spotlight the number 5, the high number of volunteers, because this project is all with volunteers. And then the last one is the number 8. I can show you here today that we finally have our book finished. So if someone wants to take a look of the book, they only need to talk with me, and I will show you. And then finally, on conclusion, we want to make a brief summary that we work on equality for all, also to have an energy guide to help that type of people with energy poverty, and finally also works on SDGs, not only the number 7, we also work on some of these SDGs. So a special thanks to EELISA Communities, to all of you staying here today with us, and also Madrid Towns Foundation, the students that have involved, and also the professors who have been doing a very good work with us. So thank you very much.
Well, I'm going to talk about and present the Get Active project. Get Active is a program that has been developed through the collaboration of two entities, Proyecto Hombre. Proyecto Hombre is a Spanish organization which helps people with addiction problems. It could be with substance consumption or with a problematic use of technology. On the other hand, the UPM, through the learning service methodology, some professors and students were involved in that project. Proyecto Hombre has a weekly program which is designed by some experts and it is adapted to each participant and situation. All the original program were held at their organization facilities. While they were doing the Get Active project, they attended 2 days to our facilities, to the university's facilities. On Tuesday, they worked on sport activities at the Faculty of Physical Activity and Sport Science, while on Thursday, they attended 2 technological workshops at the School of Computer Systems Engineering. All the activities were designed by the experts of Proyecto Hombre and the professors of the UPM. The students who were involved, we participate in all the program activities and we acted as mentors of these participants. Now I'm going to be a little bit more focused on the sport part because, well, addiction is an increasing public health problem in which more and more adolescents are becoming addicted to drugs or technological devices. This addiction has a substantial impact on their mental health and quality of life. Furthermore, we cannot ignore that this addiction is a major risk of social exclusion for these young people. So, in the search for effective rehabilitation programs, physical activity has been observed as a potential strategy that needs to be explored. For that reason, this study has established as a main goal to assess and understand the changes in patients with addiction problems following the participation in a group physical activity program, and to fulfill this objective, a qualitative research approach was developed. With regard to the intervention program, there were 10 participants who were undergoing a rehabilitation process in a daycare center. They carried out 17 supervised sessions in which they combined strength training and playful and cooperative activities. Once they completed the sessions, semi-structured interviews were conducted. On the one hand, 5 participants were asked about their perceptions and possible changes achieved by this program, and on the other hand, qualified personnel who had a direct relationship with the program were interviewed to have a more complete picture of what the program was. After transcribing the interviews, the coding and categorization process was developed and 3 themes emerged from the interviews. The first one was related with the dispositional aspects. This factor plays a key role on our daily lives and has a substantial impact on our conduct and behavior. Participants described how through this program they were able to get to know themselves better and know where their limits are. They noticed a change in their mood and they found the sport as a way of relieving anxiety. With regard to the quality of life, they noticed an improvement on their physical condition and they improved their social relations with their family members and with the program members. The changes mentioned earlier had a great impact on the consume. It was observed how physical activity could help to alleviate the urge to consume, and it has a great impact on the consumption. The participants who started the project in a period of abstinence, they succeed prolonging that period through the intervention. Meanwhile, the participants who started the program using, they managed to stop using by the end of the intervention. So as a main conclusions, we could see how dispositional factors could be essential aspects of the rehabilitation programs, and according to the results, we suggested that we have to try to work on 4 key elements in order to achieve an effective recovery process. These elements are self-perception, social relations, mood, and take-up physical activity. In this way, it has been seen how physical activity programs could have great benefits on their recovery process. So before, I was talking to the more academic part of the study. Right now, I would like to share with all of you my personal point of view and my experience. because despite the methodology, the results, have you ever thought what's behind an investigation? This project was more than a simple study, and it went further. The project, as it couldn't be otherwise, it started with a lot of doubts and insecurities. But as the weeks and sessions went by, they turned into enthusiasm and excitement. I'm always wondering who benefits more from this project. Thanks to the learning service methodology, I was able to learn in an unexpected way from my colleagues and professors, but especially from these students who overcome their adverse situation day after day to come to our sessions with a big smile and initiative, teaching us great values. No sooner did I interview the participants than I realized the importance that a simple game or simple activity, physical activity, could have in their complicated recovery process. As I was saying before, this was more than a simple study, and this project ended with a graduation ceremony in which the participants graduated, but you can imagine what's like to have the parents come, of the participants come, and thank you for participating in this project, and that makes this long process make sense, and I felt, and right now I feel, really fortunate to have been able to contribute, even in the smallest way, in their recovery life, in their recovery process, and in their new life. For that reason, in addition of helping the society and young people at risk of exclusion, these projects provides students to have to live a unique experience and to grow personally and professionally. Also, furthermore, it's the ideal place to promote new research lines. So, I would like to end the talk before giving the turn to my colleague with a sentence given by one of the participants, which is...
Well, thank you. Alex explained the activities developed on Tuesdays about sport. I will give you some details about the Thursdays, the activities developed in the technological workshop. Based on the experience of the previous years, we prepared in detail, we selected some computer tools that could be useful for these people, these young people from Proyecto Hombre. Some tools as Excel, Word, Canva, the use of Zoom. Very important, the edition of web blogs were included in the program, and then we established a schedule for start since February to June, including the opening and closing day. Our students in this technological workshop, the students work in group of 4, and then here you have the initial of the names of the students. We had a great number of volunteers. Here is the proof. And then each group had to prepare the material, organize the sessions, prepare the practices, the exercises, and finally they had to teach the module in 2, they had to teach at least 2 modules, each team of 4 students. And then we will come back to the common, the umbrella that covers these projects. Here in this slide is just to show what are the group of people that are involved in this kind of projects. On the upper side there is the target group, usually in our case the vulnerable groups that are in vulnerable situation. On the left we have the social science and educational experts, especially social workers that work with these groups. And on the right you have the technological part, teachers and students from engineering that develop the service learning activity. And then, obviously, these 3 groups have a different perspective of the same problem. Here, in the middle, we have the social challenge, and the perspective of each group, obviously, is different. We will pay attention to the different perspective of the social workers and the teacher and the students from the UPM. I will show you this different perspective with an example. The example is the workshop that we are organizing for September with Ashley, that mentioned in her presentation. We are organizing a workshop that is aimed at giving some basic social science background for engineers. And then initially engineers proposed this title. The title was Technology for Social Challenge, Turning Up Aims. Turning up aims means that actually engineers are thinking about what are we doing with our technology? Where are we putting our eye, our focus? Okay, according to what we think that the vulnerable group need. And then, but actually the question is, do we know what is the real needs of the vulnerable group? And then the title suggested by the other part, our colleagues for social science, was a little bit different. The title suggested was technology that is up to the task. You can see the difference. Actually, they are saying us, please, rise up a little bit your goals in order to provide real solutions for the vulnerable group. And then here is the next reflections for engineers. Are we really solving something with our technological solution? And then we go back once again to the triangle with the three groups involved in this kind of projects. And then the goals are established in a collaboration between the social workers and the people from the technological school. And we have to design the programs. And then our students, as Alex and Dario, have to develop the actions, working together with the vulnerable groups, the target group. For instance, one of the actions that we have described is the technological workshop. And then actually social workers said us, well, you have prepared very detailed, in a detailed way, we have prepared a very good content, very good practices, but you are failing in one thing. We were failing because we hadn't taken into account the interpersonal relationship. Actually, we realized that we, teachers and students from the UPM, were like this, and the vulnerable group from Proyecto Hombre were here. And the relation was very cold, very cold. And then actually we realized that we had to integrate in the program, in the activities, in the methodology, some interpersonal relationship. What is the interpersonal relationships that we want with the vulnerable group? Probably most of you have visited London, and you use the underground, and you have this message in your head: mind the gap. Mind the gap asks us to be careful with the gap that there is between the train and the platform. The feeling here is the same. There is a gap. There is a gap between the students and teachers from the technological. Okay, I'm finishing. Thank you. We realize that this problem, taken from the underground, London Underground, we feel that we have the same problem because there is a gap between the vulnerable groups and the technological people that are organizing the activities. And then this is the next question: what do you need to save the gap? We are proposing some actions, some activities in two levels. First, in short term, to obtain short-term benefits. We are going to foster those activities in which these vulnerable groups improve their self-esteem. For instance, in our case, in the Technological Thursdays, the edition of blogs, we realize that it's really important for them, because not only they are learning how to edit a blog, a web blog, but it's an activity where they have the opportunity to show the motivation, even if they want to show who they are to the world, and then promote this part of the activities. The second one, next year it will be compulsory to introduce seminars for mentors, seminars leading to give information to keep in touch with the reality that they are going to work with. It's not the same to work with refugees, young people with addiction problems, or people who are in energy poverty situation. And then put in touch the people from technology part with this reality to synthesize these people. And finally, this kind of organization, DAWN organization, Proyecto Hombre organization, they develop activities out of the classroom, and we want to participate in these other activities. And in a higher level, We are organizing, in order to obtain more midterm benefits, we are organizing, as my colleagues in the previous presentation explained, we are organizing some workshop, the design thinking technology for elderly people that was held in Bucharest, and the social science garage emergency workshop for engineers that was held in Madrid, working together with our colleagues from Istanbul and Bucharest. We are organizing a new workshop. Ashley mentioned this workshop. I love the title. This title won, the title proposed by Ashley, Technology that is up to the task. And then in the midterm, we would like to integrate a course like this in the catalog of the EELISA in order to organize a regular course that help us to bridge the gap between the society and the technology. Okay, thank you very much.
Thank you. Thank you, Javier. Any questions for Dario, Alejandro, and Javier? Yes, Òscar.
No, it's not one. So, congratulations for very nice presentation. So, I have like two questions and comments. One is related, since we have here the students, so if you can tell us, and you mentioned briefly, if you can tell us a little bit more about which competences or which soft skills have you learned on this project, or you think you have learned on this project. And as well, something related about this gap that you mentioned, I think is very important, because basically that's what we're trying to say in my presentation. So this gap between the university, students, and society that is represented by, in that case, with the associations on GEs that you're working. So this gap, through as well the social science perspective, maybe could be the mediation, okay? So this external factor, this external expertise that we don't have in our university that help us to connect with this interpersonal interpersonal kind of communication or gap that you mentioned. So it's something that we can maybe develop more in our next events. Yeah. So, but I'm very interested about the soft skills that you think that you have learned, because you have the technical ones. So what about the others?
So I thank you for your question. I find it very nice. So I'm going to tell you the truth. When you have the offer that, hey, do you want to work with us in this type of project? The first what you think is, oh, I don't have trade with people with disabilities. I'm a little bit, I don't know, scared. But then when you start working on the project, you start thinking that, oh, it's nice people. They also give us other point of view of the life. So I think the most important thing I have learned in the project is that we are focused on mathematics, physics, but we lose like the idea of what we are doing. I mean, I'm learning installation of evacuation of water. I know how to build a house. I know what I need to do. But with this, I finally find the way that I want to follow. I mean, okay, I know how to make this, so now I'm going to share to the people how all we can make like the good way. So I think that to be human, to be focused on what is important to have results on the project. So I want to highlight that the idea of not being focused on mathematics. So what I learned, I mean, put it on practice.
Well, as Javier said before, it's complicated dealing with different type of population. It's not the same to deal with my grandma than with people with addictions. So I think that this program helped us to enhance social relations with people who are in an extremely situation, because it's tough seeing people that is your age and they are in a really bad situation, and I don't know, it's
I can explain with words because it's like a personal experience that I encourage you to live because it's really special, and the way that they thank you for being in that process, in that complicated situation, it's seriously, you have to try to be in that type of projects. And the second thing is that sometimes the degrees are really like a focus in the theoretical aspects. But then what you have to know how to apply what they are telling to you. So I think that with these projects, we are able, for example, in my case, to program sessions for different people. For example, now we are going to go to the gym. I have to make a session to work strength. Later, we are going to play some games, cooperative games. And it's really nice to apply the things that maybe it's around of your head, but you can't focus in that aspect.
I think you just mentioned that very important, both of you, because it's like empathy, work, cooperation, strategies of communication, so a lot of soft skills. Okay?
Yeah, sorry to interrupt, but we're really running behind. So Alia, do you want to add a few words?
No, actually, we are working in many projects, and then we are discuss a lot of the really interesting. This gap, he was working talking about the gap. This gap, I see that it produces first insecurity and fails in our work, and then we have to reach this gap.
Thank you. Hopefully we'll have time in the afternoon, as you probably received an email. There's a meeting at 2 p.m. In the room, and there perhaps we can talk this, and I'll do a little self-promotion. We have some funding for Istanbul, also from Scuola Superiore, and we have any Italian students, so we all hope that you come and join us in the workshop at ITU in Istanbul in September. Heard any of what I said? I hope you have. Next speaker is İsmail Bayezit from ITU.
Thank you, Hocam. Hello, everyone. This is İsmail Bayezit. Actually, it is my second talk within this symposium event, and I would like to tell more about our community activities with EELISA partners and out of EELISA partners, and our targets and aims, actually. So this is shortly me. Yesterday I introduced myself. I'm an assistant professor at Istanbul Technical University, member of EELISA team within ITU, and work for many like citizenship activities within ITU and research and teaching activities as well. So I'd like to start with my belief on these community activities, which I believe it is really important, because it is one of the three pillars of the academy. Actually, today I'm talking more about the science institutes or engineering institutes. So if I consider the academy as the ceiling, head of the building, research, industry, and community, which includes mobility as well, is the three important pillars of the academy. So that is why our activities that I'd like to describe today are pretty important in the sense of building up our academy. So our community names flight tests and experimental models, which was built by Professor Petrișor Parvu from University Bucharest, Politecnico Bucharest. The main aim is to develop a culture, technical culture, and disseminate our knowledge on autonomous, semi-autonomous systems designed for smart cities. And what are our activities? Shortly to bullet up, learning from each other. We learn from each other. There are student internships and exchanges, internship exchanges, site visits to learn also from each other, and some lecture exchange, enhancing capacity and search for collaboration within EELISA countries and also within Europe or out of Europe, that I'd like to shortly show you from our activities in the follow-up of my presentation. The rest of, we are creating project proposals and try to co-create the smart cities with our community members. So we applied and succeed in two together with Sant'Anna and ITU, UPB, and FAO is also supporting us. We are organizing summer schools, competitions, and internship opportunities. So this is our warfare. This is our intended zone to build up, to develop. As you see, it's a urban mobility, smart city, urban mobility environment, where you come up with aerial nodes, ground nodes, and cannot be succeeded with one person. Today, there are many levels of autonomy, starting from level 0 to level 5. And all of the companies and most experienced institutes today believe the level 4 and level 5, today Tesla, for instance, is in the level of 2. Mazda just built up a new car for cities, and it is in level 3, but not fully level 3. Level 4 and level 5 autonomy can be achieved with collaboration, with community collaboration within companies, so within institutes. That shouldn't be only intended to like create some goods for making money, instead of creating prosperity and good technology with togetherness or community activities. So there are, that is why there are many open environments today in the world where people are building up the technology together. So the challenging points are, there is a lot of important tasks need to be developed under like industrial defined under Industrial Revolution 4.0 and on smart cities. There should be we need a coherence in the mixed environment, because there are many dangerous nodes. Humans are there, animals are there, and also machines are there. There is manned and unmanned mixture of things there. And we need definitely real-time situational awareness for everyone. Then we need to think about also GDPR and some rules that we photo everywhere, and people are there, and there is somehow private life there. We develop technology, but we care the other when we are developing the technology I mean, there is also social aspects besides the scientific aspects. And we need a high precision in sensor applications. Then I'd like to switch after telling about, and we are fully business or civilian oriented society, no orientation or no intention on defense. Just building up together for civilian prosperity and peace. We organized a summer school for teaching flight control theory and applications for 15 students from 9 different countries within ITU campus. I was one of the volunteered instructors of this event. And it was sponsored by Istanbul Technical University and Yunus Emre Institute, which is a non-profit organization under Cultural Ministry of Turkey. This is one of the shots together with my teaching assistant and the student itself. And we give lectures on flight theory. We give lectures on MATLAB and simulating such model-based design environments. And then we go to the field testing, thanks to the support of Turkish Aerospace and Altınay companies. They provided us their test beds, and we do flight tests together with our students. Actually, we will have a chance to do indoor testing. As you see, there are already available test beds, and we buy some Mambo drones to do some developed some control applications together with our student groups, and then that will be first tested in indoor, and then we go to outdoor testing together with the students. Is the very eastern side of Istanbul, near Tuzla site. There is a flight field test zone, and then we do these testings in a secure way. There are other student projects, engagements, where we develop the skill sets of the students that they will get ready for the industry or some more technical works. In the meantime, due to the time limit, I cannot share all pictures, but we will have also site visits. Some part of these summer schools was in Brașov, together with Patrice Parvu, so we will have a site visit to Bucharest and Brașov to do some testing and some laboratory lectures. So here we developed a flight unconventional novel aircraft technology, and these are the indoor testing together with uses some tools like requirements analysis tools and indoor testing with our test bed, hardware in the loop test bed, and then our students are tuning their controller parameters within, and then we go to outdoor testings. As you see, this platform fully built up by our students at ITU, and one of these are awardee, one of the awardees I will show you later, and the other one is developed for some internal projects at ITU. So we test load of high fidelity models and load of control algorithms within these test beds together with our students in order to enhance their skill sets. So that is one of the two of the, like in different years, two of the participation to IMECE in UK, Manchester challenges, and our students, as you see, among a lot of different teams, even the UK teams, were the awards, Grand Championship, taking the Grand Championship awards and some other awards, as you see in the listing. Like in the previous year, it is taking like Manufacturing Award and Best Flight Readiness Award, and the follow-up year, they took Grand Championship, Safety Airworthiness Award, and Best Flight Readiness Review. We also have some collaborations and developments for marine systems. We worked on hydrodynamics and hydroacoustic modeling and testing at ITU, like shipbuilding and ocean engineering faculty. This is one of our indoor tunnels, Atanutku Tunnel, which is, there are very good facilities, especially for ocean engineering, ocean technology, shipbuilding. Within ITU, it is the strongest one in Turkey, let me say. So we have first designed one 18th scaled DTC, Duisburg test case ship, and we start our testing of our avionics and our system within this Atanutku tunnel. And then we go outside. Yes, I checked it, hocam. We go outside, and then outside we are creating real tests. I will show at the end of my presentation our real results to you, and then you will see real video if you have questions I'd like to take. So we developed hydrodynamic models. There are some hydroacoustic testing. So we published already. This project ended up last year, beginning of last year, and then we published already many papers within this testbed. So these are photos from our international visits and mobility activities in 2022 and 2023. Some of them are visits to us, and some of them are our visits to other countries. This is a lot of visits from Malaysia, UPM, and some other university, Putra Malaya, Teknologi Petronas. The members of these universities visited our faculty, our university, meet up our rector, our deans, and we have a chance to share or disseminate our science culture and our findings or lessons learned or learnings from our developments within EELISA umbrella, under the EELISA umbrella. Then at the end of the day, what we create a collaborative project proposal. It has not been announced yet, but hopefully we will succeed. So we offered this, and our Turkish Science National Institution and MITE from Malaysia Science National Institution opened a project call, joint call, and then we applied, and we still wait for the response. We applied the beginning of February, but decisions takes 2-3 months. It has not been announced yet, but hopefully we succeed. So these visits, our community activities, I believe is really fruitful. And some of activities that I did also in Malaysia last year and Santo Domingo, Dominican Republic. And these are some shots that from my lectures and some of our sharings. Thank you very much. At the end of the day, they are the numbers of our achievements. Thank you very much. There's very last final video. Maybe someone supports me, or I will open myself. Thank you very much. Yes, that one. So I'd like to show you our campus. We have a very beautiful campus site. That's why I also shared like this video. Autopiloted one. We are able to do some hydroacoustic measurements that we put some hydrophones, you will see shortly, and there is INS and GPS sensors on board. That is in our campus, actually. This lake is inside our campus. These are measurements from our maneuvering testing. They are inside the water, and we are able to measure, as you see, the hydroacoustic noise inside, coming from our nodes. Thank you very much. That's it, actually.
Thank you. We don't have a whole lot of time, but still perhaps we can have one short, quick question to Dr. Bayezit.
Thank you very much, Hocam. Yes.
I can speak up. I have one simple question. How do you evaluate the security of these autonomous vehicles and the impact through the transaction?
Hocam, thank you very much. Professor Andras from I always confuse with Bucharest and Budapest. From Budapest, I believe. Sorry about this. They are very closed words in English. I know they are very different countries. The security, Hocam, actually in autonomy we worked on SOTIF and cybersecurity. They are under ISO standards. We are in our programming. In these test beds, they are mostly institutional, not really industrial. But in industrial ones, we are aware of this AUTOSAR, cybersecurity, and SOTIF standards, and we are designing our software under ISO 26261, like functional safety, and SOTIF and cybersecurity we are aware of. So we are aligned with these standards and aligned with the industry in order to design this secure software for autonomy, let me say. Thank you very much, hocam.
Thank you.
Thank you.
Thank you.
I will.
Thank you, Simona.
Yeah. If you have like follow-up questions, we will discuss in lunchtime.
Thank you. All right, our next speaker is Silvia Merino de Miguel.
Thank you. Thank you. Good morning. Thank you to the organizers for bringing us to such a beautiful place. How do I have a pointer? No. So my name is Silvia. I come from the Technical University of Madrid, UPM. I'm in the Forest School of Engineering, and I belong to the Green Planet community. Today we will talking about a project in which we have been involved that is called the Metropolitan Forest. Well, the Green Planet community was born in April 2021. I would like to emphasize that it was a really new group. We never have been working together before this moment. And in the Green Planet community, we try to join people from different disciplines within the Technical University of Madrid. That is basically a group of schools of engineering. From the beginning, we had a very clear idea that we have to open to other members in the EELISA group. So we met, from the very first beginning, we met Professor Ana Maria Radoy and Professor Bezet Torregin, that are really nice people. And since then, we have been working together in different activities and different meetings. Well, even though we would like to have more push pins in the map, if possible. At the beginning, we thought of the Green Planet community having the mission of preserving our green resources, our green planet, using intelligent technology. That was the basic idea from the very first beginning. We tried to develop this mission through action, and action is something we thought being a big project that I will explain a bit more later. This action will be, every action we were able to build will be developing activities, using different models and methodologies, using different data and approaches. And at the end, the idea was to generate capacities in our students, but also capacities in our staff. We also were very aware about the fact that we need at some point to assess the impact of the activities and the actions we were carrying out, and also be very on the participants. Well, what is an EELISA Green Planet Action? As I told you, it was thought as a big project, like a framework that can be split in smaller projects, that can be translated into smaller activities, depending on the time gap for the students, for example, or depending also on the engagement, no? What was the level of engagement of our students or our staff. And in this sense, also was very important, the participants. I also like to think about this action like an environment where you have different elements, external elements, you have processes, and everything is working in an harmonious way. Well, following this concept, we thought that an EELISA Green Planet action should fulfill certain or specific requirements or traits. For example, it was very important for us that these actions had social and environmental engagement, for example, that were either interdisciplinary or multidisciplinary actions or projects, and they have to be also technological challenging, and so on. This action, we thought that we will be able to create opportunities for developing different activities, but also to integrate participants from different, especially from different environments, from different backgrounds. At this moment, we had, with this idea in mind about the action, not like activities, individual activities, but something that was like a framework, as I said before, we had to talk about two big projects in the Madrid City Council. One is the Metropolitan Forest, and I will talk about it a little bit later. So we decided to take this example, the Metropolitan Forest, as a possible Green Planet action. The objectives were two. The first one was to create a framework to work with the City Council in a real project, but also to contribute to improve the environment of the city and probably the most important, to engage students in a real project. This Metropolitan Forest project, as I will show you later, can take people from very, very different backgrounds because it's quite a big thing, let's say. At the end, we feel like this societal need, the need of green areas, the color, that concept have been appearing in other talks. We realize that these societal needs can drive to new opportunities both in teaching and in research. Well, this is the Metropolitan Forest. It was thought as a strategy for mitigation of climate change, but for me it's more like a way to improve the people life, the lives of people living in a city. It's like, as you can see, it's like a green infrastructure, quite big. It is 75 kilometers around the city, so it's quite big. And the idea is to connect the green areas around the city, but also to allow corridors to get into the city, maybe by walking, maybe by cycling, and so on. Who was participating in this Metropolitan Forest? Of course, the City Council, but also citizen organizations, NGOs, private companies. And within the Green Planet community, we had the students, we have faculty staff, and we have some private companies. So this is how the Metropolitan Forest became a Green Planet action. At this point, we take advantage of the joint call and apply for it. So we get with this joint call creation and startup of a multidisciplinary territorial information system for the proposal of activities within these two big projects, mainly the Metropolitan Forest, but also the Producers Neighborhood project. This one, we rely on 5 important parts that are a GIS, a Geographical Information System. That is where we were able to put all the data together. We also work a lot on satellite images, and in this sense, we take advantage of the Sentinel-2 mission that you may know. It's an European satellite with very nice spatial and temporal resolution. Of course, we use maps that already exist. It was very important for us to work on the field data collection, especially for the computing people, to put them in the situation to go into the field to get information. It is really difficult to put the reality in a table, and it's time-consuming, of course. And all this was to prepare the information or the framework to support any activity that can be proposed within these two big projects. From the beginning, we were very strongly focused on the students, both thinking on the social impact of the activity, the local impact, and the personal impact in the students, but also very focused on the ELISA. We thought that this project could have very important impacts on all the levels within the community, within the universities, and also international impact, since this kind of project, the Green Planet, the Metropolitan Forest project, can be brought to other cities. It's easily exportable to any other big city in the world. Well, this is the timeline. We apply for the joint call in June, and we have a first preparation meeting in November with only staff members. And then we have 2 seminars with the students. The first one was in Bucharest in February, and the second one was in April in Madrid. The first one, the seminar that took place in Bucharest was more focused on the satellite image processing data, while the second seminar in Madrid was more focused on the field data collection. Well, these were the participants. We had 23 students from 5 EELISA institutions of all the levels, but for me, most important, for very, very different backgrounds, and we forced them to work together, to understand each other. That was probably the most exciting part of the seminars. We were 20 professionals involved, staff members, scientists, and also workers from local administration and from private companies, and these 4 private companies that were involved. Well, the first seminar was focused on satellite time series images processing and multimodal data. I don't know if you are familiar with time series, but it's basically data that is put in chronological order And it's very, very important that this data is taken at regular moments, let's say. So we can use the satellite information, because usually satellite images are taken very regularly, to produce, to generate this time series, and this time series can be analyzed to get a lot of information. In the graph, you see the signal of 1 pixel. We have millions and millions of pixels, like this one, and we can see cycles. We can see stability, like at the beginning. We can see like a drop, like a structural change, we call it, and then we can see a tendency. We can see recovery. So we try to use this time series data to know about the processes that were going on the ground, on the land. Thanks to Ana Maria Radoy, Professor Ana Maria, we went through rather complex algorithms. I get a bit lost, I'm afraid, but never mind, the students did it. And at the end, in the last day of the seminar, she proposed like a little contest between the students. We divide the students in 3 groups. She explained an algorithm using only theoretical information, and the student has to build the algorithm in Python. And I remember it was Friday, 8 p.m., and the students were on the computer. It was impossible to stop them until, fortunately, one team were able to produce the algorithm and to make it work. This was the image in fact, we analyzed. It is a Sentinel image. I don't know if you're familiar with, but this is it's a really high spatial resolution data. That is taken in a very frequent gap. We have an image every 5 days. It's not the spatial resolution of a drone image, of an aerial image, but we have 1 image every 5 days. So we can be very, we can get a lot of information on what's going on every pixel in the study area. Well, back in Madrid, we had our second seminar. We were more focused on the field data, on the field trips, as I will say. In fact, you have in green everything that is already fine. Okay. Everything in green meant a field trip. Everything in orange meant a practical sessions, and the other one were more theoretical sessions. And in this case, we made a lot of field work. It was tough. It was so hot in Madrid these days. It was too much. We had 2 people that get sick, so it was a bit of a disaster. But it was fine. It was really a really nice experience at the end. We took them to the field. We made them to measure different things concerning forest distribution, forest path accessibility, species distribution, producers' neighborhood species, and so on. Okay, so they suffer a little bit, but at the end, I think it was really great. One of the things we measure, I'm afraid I don't have a picture. One of the things we measured in field was related to the accessibility of paths within the metropolitan forest for disabled people, for people in a wheelchair or any other kind of disability. And this was one of the most nice moments, because in the afternoon we have a talk by David, that is a scientist I will introduce you in a few moments. In field, we work with different applications. I don't know if you are familiar with. They were working on their mobile phones, taking the data, putting it in the map, and so on. And one of the most funniest moments for me, can you see the green rectangle there? The green rectangle in the right-hand image is the study area. Look where all the data was taken. This group of students took all the data outside the study area. It was quite, I couldn't stop laughing, I'm afraid. So as I will tell you, one day we were measuring accessibility in the paths for disabled people. And in the afternoon, we have a talk about this guy. This guy has this awful disease, but he became, rather than being like sad and so on, he has become an active person, a very fighting person. And he spent most of the time fighting for the rights of people with disabilities. I think probably there's no time for this video, but it was one of the most beautiful moments. And at this moment, we are trying to make probably one of the most difficult tasks in this action, that is to measure the impact. We want to measure the impact on a student's life. I know the impact of my life, but we wanted to measure somehow the impact of this activity on students' life. So we made some videos, we made them to write like a report, to fill in a sheet, but we are now in this moment to take all this information and try to give a number. If it's possible, probably it's not possible. That's all. Thank you for listening.
Thank you very much, Silvia. It's a wonderful presentation. Any questions or brief comments? Sorry to rush you guys, but I know everybody's getting impatient, but any questions for Silvia? Okay, well, if you do, then you can perhaps drink lunch. Our last but not least speaker is Filippo Corsini.
Hi, good morning, everyone. I am Filippo Corsini, here with me Francesca Cecchi. We are working at the Institute of Management of Scuola Superiore Sant'Anna, and we are part of the Circular EELISA community. So we will going to present you a project that we conduct inside the Circular EELISA community.
So, good morning. Let's start with what is Circular EELISA Community. It's a community of EELISA Alliance of Universities around circular economy. And our mission, I can read, is develop resources for promoting circular economy. And here we have a small short video. It's embedded in the presentation.
A community of the EELISA Alliance of Universities around circular economy. University partners: Politehnica University of Bucharesti, Sant'Anna School of Advanced Studies, Polytechnic University of Madrid, Istanbul Technical University, and external partners from diverse industrial sectors. We are here to promote a mindset that favors the transition to a circular economy, developing resources, social citizenship and sustainability competencies to address the challenges of the future. Our vision is recognize our social responsibility and build a common vision of the strategic role of higher education in meeting the challenges of the UN Sustainable Development Goals. The EELISA Alliance is an opportunity to join forces with the objective of developing resources to better understand the circular economy and its role within social citizenship and sustainability competencies. In collaborating with professors, students and researchers. Activities we do in Circular EELISA community. Seminars, workshops and webinars. Seminars focus on participation, shared ideas and knowledge acquired. In the workshops, teamwork, brainstorming and infographics are developed. In the webinar we talk about sustainability, shared value and society.
So, as Sant'Anna, we joined Circular EELISA in last April 22, and we actively participated in 3 proposals submitted to the first joint call for EELISA community and then funded last year. So the first one was Circular at Action, coordinated by E2. That is a series of integrated activities that are constructed to introduce an innovative and creative platform to rethink education. And the second one was Circular in Play, coordinated by UPM and E2 together. That was a trilogy of gamification events to enhance knowledge and awareness of the circular economy. And the last one was Be Circular webinars, coordinated by Sant'Anna, that Filippo will show you. So the first one was Circular at Action, and we hosted last January the workshop, Our Mechanism from Linear to Circular, and organized by E2 and hosted by Sant'Anna, where students work around the circular economy methodology. We also invited an Italian artist that made some art pieces from garbage and recycled elements. These are the three events, trivia nights that we organized last year. The first one was during the European Researchers Night on last September, and the second one was the Circular in Play escape room, so an escape from linear economy through collaboration. And the last one was Art Express, so a circular economy journey to re-envision destiny, why, what, how, and when. So during these online events, students, around 30, 40 students per event, play with us and discover some basic elements of circular economy. And then I leave the floor to Filippo that will show you the circular webinar.
Okay, thank you very much. Indeed, we organize these circular webinars. This activity was mostly organized by us. The aim of this project was to provide students a background on circular economy. So we try to explain them what circular economy is and to provide them some general knowledge, I would say, about circular economy. So in order to do so, we organize different type of activities, as you can see in the slides. We organize webinars online. We organize laboratorial activities that were held in Pisa, and then we organize also field trips. By adopting these multiple approaches for teaching them what circular economy is and why it's important and which are the main skills for developing a circular economy, we, as you can see, we aimed at providing them the opportunity to apply theoretical concept with laboratory activities, but also understand what the circular economy is with field trips. So this is a snapshot of the webinars. The webinars were mostly organized by us, but webinars were given by the 4 partners of the Circular EELISA community, so by Sant'Anna, by UPM, UPB, and ITU. And the seminars were approaching circular economies from different backgrounds and from different topics. Each webinar was 1 hour and 30 minutes, and we provide the participant with a badge, I will show you later on, in order to increase participation in this kind of activities. Based on the participation in webinars, we selected then students that were allowed to join us in Pisa for the workshop event, where we had some laboratorial activities, as I told you, and then the field trips. This is indeed the workshop that we hosted in Pisa. We hosted, I would say, 2 days workshop in Pisa. The title of the workshop was "Be Circular Webinars, the Role of Businesses and Governments," in order also in this workshop to show them the importance of different stakeholders in going through a full circular economy, to moving toward the paradigm of circular economy. So we had some lecture plus laboratorial activities and field trips. You can see here a presentation of the laboratory activities. Laboratory activities, as I said before, are good for applying theoretical concept to a real topic, a real-world topic, I would say. And those laboratory activities were also good to work together between students and try to teach them how to solve problems, which could be the circular economy problems. As I said to you before, we also hosted several field trips during the workshop in Pisa. The field trips were to visit a landfill facility and then a recycling facilities. And we think that by providing them with field trips, they could touch with their hands the difficulty to move toward the circular economy, but also better learn about the cycle of waste management. But for instance, they had the chance to see how innovative technologies work in the waste management field, and understand which are the main drawbacks of the linear economy model. A part of the field trips, as I told you, was done by visiting a landfill. And we think that there are many benefits in showing students what a landfill is and how waste are managed in a landfill. First of all, as I said, landfill can be a good example on how the linear economy works, the take-make waste model work, in which resources are extracted from the biosphere, products are produced, and then at the end of their lifetimes, those products become waste. So visiting a landfill that was the first experience in the landfill for many of those students was incredibly useful for them to understand the consequence of the linear economy. But visiting a landfill was incredibly useful also to teach them there are also, landfill are also useful in a circular economy context. Not all waste can be recycled. But we need also landfill, and there are also best practices in landfill management. The landfill that we visited is a landfill that is located near Pisa, and is one of the most famous in Italy for the way it's managed. As a part of the field trip, we also visited a recycling plant. There are many benefits also in this case for visiting a recycling plant. Have tangible example of how circular economy works, but visiting a recycling plant that also in this case was, for most of the students, the first experience in a recycling plant, they had the chance to understand how different stakeholders might work in the circular economy context, and especially for recycling waste. In order to, increase participation in webinars, but also in the workshop that we hosted in Pisa, we provided participants with badges, as in many other ELISA activities. In particular, we provided them with badges connected to quality of education and responsible production and consumption. Badges were provided to students that attend the seminars, and also badges were provided to students for attending the workshop in Pisa. To conclude the presentation, we also learned many things for this experience, so this experience was incredibly useful also for us. We learned how to adapt our teaching styles to different contexts and different kinds of students, because the plus of the ELISA communities is connected to the fact that we are different backgrounds. There are many different departments in the circular ELISA community, and that was good also for us to improve our teaching skills. We learned how to better understand students' perspective and how to approach problems with them, and how to incorporate concepts from different disciplines into teaching, fostering a more holistic understanding. So all in all, was incredibly useful also for us. I have the last video. This is a video of a participant of this project.
You are the one thing in my way. You are the one thing in my way.
Thank you.
Thank you very much, Filippo. And my sincere apologies, Francesca, for not announcing your name in the